Alrighty. What's
All
happening,
right.
all?
Good
We're
evening.
here. And a happy Wednesday evening. What is this? July, what's today? July 29th?
29.
July 29th. We're almost into August, man. Is this what, when you're doing Takeo After Dark, doesn't the summer just fly by because we're having such a good time?
Right.
Yeah.
Before we know it, it'll be hot August nights.
Oh, hot August nights. And then it'll be those, we'll be trying to remember those, what is it? Try to remember the
Time of September.
And
Yeah.
yeah, whatever. Well, we're stop us before we start singing, okay?
Yeah.
Yeah, there we go. Well, good evening, everybody, and welcome to Takeo After Dark, Part 6. I'm joined by Tim Ward from Mechanical Hub. Tim's in the background. John Messenbrink's getting ready to go on vacation, which good, well deserved. To my right is Dave Holdorf. To my left is Rick Mayo. Well, we are the Takeo Training Trio. Lots of alliteration there too. Did you catch that?
Yeah,
Takeo Training Trio.
Trio.
Or trio of Takeo trainers. Lots of alliteration for anxious anchorman. There we go. And this is part 6. So it's going to be one of those nights we can tell already, right?
Part 6 of summer school.
Ooh, yes. Episode 6 of summer school. Episode 6. So ModCon piping and pumping. We're going to start out with a discussion on ModCon piping and pumping and follow that up with a primer on circulator selection. We're going to go over that again. So we understand what it's all about. As always, I just want to give you just a quick heads up on what we're going to be doing tonight and how this is going to work. Again, if there are any first timers in there, then keep your heads up. Look on your control panel. If you see this here orange arrow, if it's pointing to your left, then click on it. And if you click on it, that's going to expand your control panel. Okay, that's going to expand your control panel. And when you expand your control panel, what you will see is this, one of the things that will come up is this questions chat box. And that's going to be how you ask your questions. All right. And if you haven't guessed already, I think you can guess the theme of this evening. All right. It's Monty Python and the Holy Grail. And go away or I shall taunt you a second time. So that's how we roll tonight. That's how we roll tonight. And a good evening to everybody. Mr. House, Mr. Whelan, Gary Scarborough's in the house, Daniel Leary, excellent, very good, very good. Happy to have you all here with us this evening. And we're going to have ourselves a grand old time. So we might as well get this show on the road, huh? And maybe that's what we should call ourselves tonight, the Knights of the Round Table. What do you think, Dave?
Sure. I like it.
Yeah, no, we'll go to Camelot and drink ham and spam and well, whatever. Never mind. I think we should just continue. We should just how about this? How about I shut up, and we're going to get right into ModCon piping and pumping, and we're going to turn it over to our very own King Arthur, our man from Provo, Utah. The man,
not Provo.
Not Provo.
Sandy.
Sandy.
Is Sandy near Provo?
Well. Far enough away, let me put it that way.
Far enough away. Okay, so here's our man who is nowhere near Provo. It has absolutely no linkage to Provo whatsoever.
It don't matter.
Sounds like fighting words, man. Holy cow.
We're going to turn it over to Rick Mayo, who's going to talk to you about ModCon piping and pumping and a very interesting take on sizing pumps for your ModCon boilers. So take it away, Mr. Mayo.
Show my screen. 10-4. Well, let's jump in and make this thing happen. Tell me this. Do you see what I see?
I don't know what you see. I see a presentation on ModCon boiler piping, but what do you see, Rick?
Okay. I'm going to shrink that thing down and get rid of that. All right. Well, welcome everyone. One thing that we want you to understand about this, John mentioned it a little bit already, is that we have lots of different boilers pictured here. Some are floor mounted, some are wall mounted. They're all modulating, condensing pieces of equipment, and they have AFUE ratings of 95 or 96. Very high efficient, possibility for these units. But one thing that we try to emphasize, because we're circulator manufacturers is that the circulator has a whole lot to do with the efficiencies of these products. So understand the circulator sizing in itself can help these these pieces of equipment actually obtain higher efficiencies. So what we're going to look at real quick here is just the primary, secondary, configuration. So we're going to focus on this circulator in particular, as far as the sizing, and this little configuration here where we have people have called it closely spaced tees, tees that have been butted together, and we'll get into some of those details as well. This is another configuration that we've seen out there, but for the most part, this is what the manufacturer shows you. And I should just make this clear right now. The manufacturer of your boiler will give you drawings in the manual to show you how they prefer their boiler to be piped. I'm giving you some general statements, but there's still some people out there that have piped it in this boiler loop configuration. And I guess what I'm going to focus on is we're still talking about this particular circulator and these T's and these little A's and B's, and we'll get into all that stuff as well. I will say this, some of the boiler manufacturers out there have an external signal, a control wire signal, a control signal that you would run a wire from the boiler to the circulator, and they control the speed of this pump based on some input that the boiler can actually see, which is a good thing, and use it to your ability. So if you have it, great, but here's the two things that have to match up. The boiler has to be able to give the signal, and the circulator has to be able to receive it. Taco has circulators that have those signals. They're typical of 0 to 10 volt DC or pulse width modulation. But our littlest pump right now, and you'll see where I'm going with that emphasis on littlest pump, doesn't have the ability to receive that in an ECM offering yet, okay? And since we've all kind of graduated to the high efficiency circulators, I'm making note of that. Taco by all means does have a circulator that receives the 0 to 10, but oftentimes it's actually bigger than you need. And that's what we'll get into in my short little session tonight. So we're focusing on this circulator in that configuration. Now, when we're talking about the sizing of this pump, it's important to know that not every boiler manufacturer, or the circs aren't small enough to have a 0 to 10 volt, then we're going to size this on and run it under a condition we call fixed speed. And if we do that, we just want to make sure that it's sized correctly, because oversizing, again, will lead to poor boiler efficiency. So near boiler piping, modulating condensing boilers. The whole idea and the concept about primary, secondary is to get this thing called hydraulic separation. What we're trying to do is make sure the boiler circulator never affects the system circulator or vice versa. It gives us that good separation where the two can operate independently of each other. Okay. What we're trying to do is make sure that if it's done correctly, the pressure drop of the boiler's heat exchanger is never has to be taken care of or considered by the system circulator. Okay, so all the boiler pump has to do is worry about its heat exchanger and a little bit of incidental piping. Then the system pump, all it has to worry about is what's within the system, and the two will never talk to each other if it's done correctly, and we'll emphasize that as well. Now, as mentioned already, when I showed you the little control wire coming down, some boiler manufacturers give you the ability to control the primary boiler circulator speed with an input, 0 to 10, pulse width modulation, or something like that. And again, check it out. If that's something that you have available, then look into it. And there's other ways around it as well. And for the sake of time, I won't get into that, but we'll spend some time, some other time, talking about what we could do to the boiler primary just without having any signal and still get some variable speed there. So another thing that we want to focus on, and we'll show you some pictures of this. It just makes sure we don't short cycle. And I'm not talking about the boiler banging on and off, although that could be the end result of it. What I'm talking about is the heated water that the boiler's just produced actually going back into its return and actually warming up the return, and that's not a good thing. So anyway. So most of your boiler manufacturers will show you pictures in the back of the book that tells you the way they want it piped, okay? And many of them, not all of them, but many of them show you the primary, secondary configuration. So again, follow the boiler manufacturers' tips and tricks, and they'll keep you out of trouble. That's the best way to keep yourself from going to jail, so to speak. So here's a picture and a blow up of primary, secondary piping configuration. In this case, you know, I'm using these little notes, the A's and the B's and the C's, and it is pretty simple once you get the concept in your head, okay? So here's that same configuration. Let's say it's a floor mounted boiler and I'm pumping into the boiler here, and here's my system, and it has a pump on it. Just again, I'm focusing just on this section right here. So here are the rules. This will keep you out of trouble in good old primary, secondary. The A note, notice it's right here, right? The A note says that these two T's, the spacing between these two T's is going to be relatively short. Anytime you see the word maximum, don't use that as your guide to cut a piece of pipe. Okay, that they're just saying don't exceed this. In fact, what that means when it says maximum is actually make it closer. Okay, so the maximum spacing in between these two T's is 4 pipe diameters of this secondary portion of the system. So if that secondary portion of the system was 2 inch, what's 2 times 4? I better be less than 8 inches there is what the A note means. Just keep them together. I got some other slides that'll help you, help this gel in your mind, so to speak, okay? Here's a good analogy, and we were talking about this because we've used it before. I want everybody in the audience to look at me for 1 second. Hopefully you can see my hands, and I want you to take one fist and hold it up like this, you know, make a thumbs up and give the left thumbs up, and take these two like this and put them together, because basically that's what we're doing. If this is one T and this is another T, that's what we want to end up with. We want them right together as close as physically possible. Now I'm aware that there's, you know, the press tools out there and they want a certain distance, you know, but typically those will keep you within these maximum guidelines. So just get it as close as physically possible. Note B says just the opposite of that. As a minimum, I want 8 pipe diameters coming from left to right here, because that's the direction of flow. So I want this to be a minimum of 8 pipe diameters. And once we get past these closely spaced T's here, or the T's that are butted together, then I want at least 4 pipe diameters before anything else happens. And I'll show you on another slide why that is, okay? And we're not going to talk too much about the C note. Okay, the C note in our case is just thermal trapping, and it's normally associated with a variable speed injection mixing. It was always part of that third thing that people had to get their head around when they were doing variable speed injection mixing. But in essence, or generally speaking, it's a thermal trapping. It's saying this, that the hotter water will never naturally migrate down very far, and that's why we give you a distance there as well. So in this set of slides, yeah, go ahead.
I do have a question here. It came from Robert Dressler. Not a question, it's more of a statement. Most of the manuals I've seen say 4 times the diameter as a minimum and don't exceed 12 inches. So is there a disconnect there? Or are we?
Yeah, I'm guessing it's a misunderstanding. Go back and read that again. Normally, some of the manuals only say a maximum of 12 inches. But if you go back to the primary secondary rules, and I believe this goes back to the 1950s, okay, so it's not new information. It's been around quite a while. It is 4 pipe diameters, okay, as a maximum spacing. So the people that put 12 inches in their manual must think that everybody has at least 3-inch pipe. So that's, again, I used to work for a boiler manufacturer, and it's just one of those things they cut and paste from other people, and it's been one of those, I don't know,
may not have been proofread.
It's a misinterpretation of the original thing. So I think it's a cumulative errors, I guess the word I was looking for. So
keep them close, in other words.
Yeah, look closer at the at what the manufacturer's actually saying, and you know, if one, not all of them are saying that, I can guarantee you that. So that would be my comment. So, are we good? So understand this, if understanding the A's and B's, let's focus on A and B, okay? As the fluid comes out of the circulator, it's in a state that's kind of radical and moving around. And after us, and this was tested, again, we're going back to 1950s when they kind of figured all this stuff out, but after at you know, a certain velocity, after a certain amount of straight pipe, the water kind of mellows out. Here's kind of a visual indication, you know, this chaotic flow, you like that term? Chaotic flow comes out of here. Some people say turbulent, but it really doesn't meet the turbulent flow criteria, but call it chaotic flow as it comes out of the circulator. After a certain amount of straight pipe length, it mellows back down to somewhat of a smooth flow, or a kind of it's not truly a laminar flow either, but we just want to give you kind of a visual indication. What we're trying to achieve by that certain amount of straight pipe before those T's is we want it to be nice and smooth as it goes across these two T's. Again, once it gets about 4 pipe diameters past here, then you could put another set of T's in there. So this is a little misleading, but just get the concept, okay? That we want the water to mellow out, and it wants to be mellow as it goes across this set of closely spaced T's. That's ultimately what we're trying to do, okay? All right, so know what the pressure drop is in the boiler's heat exchanger. So, and I throw this little RTFM in there for you folks that that know what that means. You'll get a chuckle out of that. If not, look it up. I'm showing you a boiler heat exchanger pressure drop graph. Okay, there's all kinds of them out there, but what we're saying, and what I want to emphasize more than anything, is don't oversize the boiler circulator. Okay, and this is how you're capable of not doing that. You have to know what the resultant pressure drop is at given flows throughout the boiler's heat exchanger. So if you don't follow that, okay, let's show you some pictures of what will happen. And it's kind of a gradual thing. We'll focus in on this set of T's right here. So I'm going to kind of blow this up, and so you'll know what I'm talking about here, right? The ideal flow pattern, right, is to have the coolest water back to the boiler, right? Everybody knows that. It's a modulating, condensing piece of equipment. We all know that anything under about 130 F is good. 130 or lower is condensing, and the lower the better. So we always want this low temperature fluid back to the appliance, okay? So that's what we're trying to achieve, and that's ultimately a good thing, right? Another thing that people have said is, hey, what if I could get the flow in the boiler circulator to be the same as the boiler flow in the system? And I'll say this, I'll give it a thumbs up, but it's not very practical to do. If you think about that, if I have a circulator here that's feeding a flow back into the heat exchanger, and I have a circulator out here that's feeding out to the system, what's the likelihood of those two to give me exactly the same flow and head? And it's almost impossible. Okay, so without balancing apparatus and adding a bunch of time and money to the system. So anyway, or, you know, then just pipe it without primary or secondary if the boiler manufacturer will allow it. Okay, here's where we get into trouble. When you oversize your boiler circulator, you're going to get this, and I'll make a upfront statement. You're going to get a little bit of this anyway, especially on those shoulder condensions. You know, when we're not at design, or just the pump, unless you have a circulator has a very wide range, and unless you have that feedback coming from the boiler itself to vary the speed automatically of the pump, you're going to get a little bit of this. So there's no way around it. With a fixed speed circulator. However, you can keep it, or you could make it a lot better by following some of these tips that we're going to give you, okay? So as I oversize the boiler circulator, I'm going to bypass, some of that is not going to go all the way out of here because of hydraulic isolation, right? I'm going to come right across the top of these two T's, and I'm going to warm the water going back to the boiler, which is not a good thing if we're trying to obtain the lowest temperature coming back to the piece of equipment. Okay, so I'll give that a thumbs down for you there. So hopefully that concept makes sense to you. Let's go to the boiler manufacturers. For the sake of time tonight, we're just going to show you a couple of them and kind of make this a little bit faster. I'm going to pick a boiler that's around 150,000. This happens to be a 155. It happens to be from this manufacturer right here. And what I want you to understand is understand what they allow you to do in writing. Okay. In this case, they show you a 20-degree delta, they show you a 25, and they show you a 35-degree delta T. They actually could show you the maximum flow they would want to ever see, in this particular manufacturer does, and the minimum flow at both high and low fire. Just make note of that. You know, you want to stay, they put that on there for a reason and want to stay within those parameters. This is what the graph looks like when you put a certain amount of GPM through that boiler's heat exchanger. You're going to have a certain amount of pressure drop, and that's what the, you know, that's how they show you. In this case, this is dotted line is 155, and they've got these points on here that they just pointed out to us. Okay, so just to emphasize that, you'll see what we're doing here. In this case, I need a little over 8 GPM to give me my 35-degree delta T. Look at that. That's only 1.5 foot ahead. Okay, so that's the emphasis. I'm going to throw these all up there and point out, even at a 20-degree delta T, you don't have a lot of pressure drop through that heat exchanger. Okay, just note that it's always listed in the manufacturer's information, and this is typical of many manufacturers. Okay, I'm just showing you a couple. Here's one from Weil-McLain. So they're actually giving you, in this case, we got that boiler 155, and they're showing you a 20, a 30, and a 40-degree delta T on theirs. Okay, so this is in writing, this is what they'll allow, and this is what they're telling you to anticipate. One thing about this particular chart that's a little different than others is Weil-McLain actually puts a little bit of extra fudge factor in there, and what that means is the flow, the resultant pressure drop with the flow through the heat exchanger with some incidental near boiler piping, maybe some fittings or stuff. So just make sure you understand that they've already, you don't need to double dip, and I'll show you what we're talking about here in a second. But let's go ahead for the sake of time and just show you that same range. There's a 40, there's a 30-degree delta T, and there's a 20-degree delta T. So notice that, okay? Well, even with the pipe valves and fittings and everything, they're saying it's around 6 feet ahead is all, okay? So understand, these are representative of a fire tube heat exchanger. If you're using a water tube style, then you know, the pressure drops will be a little higher, but it's all the same information. This is all good information you can use on any style of heat exchanger. But when we're talking about fire tube heat exchangers, these are buckets of water. You don't have to really do a lot to get any flow through them. Many of them will have minimum flow requirements. So as I showed you on the one document, check with the manufacturer on that as well, okay? So the sizing of an ECM. Now, the boiler manufacturer just gave you a lot of information. I'm just showing you how you would come up with that information if you didn't have that information from the manufacturer. We'll always need what the input of the boiler is. We'll need to derate that input based on altitude or / caloric value of the gas that you're getting from that utility. Okay, so that's actually the first kick to the shins of what that boiler's capacity is doing. Then you have to reduce the amount that the boiler can give you based on the efficiency, and that's always based on the application. Okay, if I'm always got really low return temperature, let's say I got 100 or less coming back to this thing anytime it fires, then you're going to have really high efficiencies. But on occasion, if you're doing domestic hot water or you're doing high temperature where the return temperature is elevated to the point where you're not condensing, then you have to take that efficiency down in your circulator sizing. Okay, so it's this in a nutshell. Take the input minus anything for caloric value based on altitude, minus the efficiency of that particular unit at the given application, and that'll tell you what the maximum output is. The other thing that's in consideration is, folks, is that do you Or will you ever have that boiler go to high fire in a central heating call? That's something, that's a little sneak question there. I'm getting low on time, but we won't elaborate anymore, but I want to throw that out to you. How often will your ModCon boiler ever go to high fire in a central heating application? So anyway, boiler sizing, boiler circulator sizing at sea level. We're not going to show you the high altitude stuff. We're just going to jump right in. Same boiler, 155. Let's say it's at an AFUE listed 95% efficiency. We take that 147, 250, which is nothing more than this times this, right? And we divide it by a delta T of 30 degrees. I'm just saying that's probably a good starting point as long as the manufacturer lets you. And widen it if you can, okay? 490, just pretend it's 500 if you don't know what 490 is. All 490 is just 500 in a high temperature. So when water's elevated in temperature, it's less dense and it can't carry as much energy. So we use a multiplier change there for our constant that changes that. So it's 14,700 as a result of this. So that tells me I only need 10 gallons a minute to do 155,000 BTU boilers. Most people would, at the minimum, would put 15-gallon minute pump in there, just using the good old shooting from the hip. Okay, here's the same boiler at a lower efficiency. So again, 0.86 gives me 133.3, 30-degree delta, 490 is my constant. That just says I got 9 gallons a minute. That's all I need. So it's always you know, your GPM is going to be based on what the boiler can do at the specific job you've got it on. So you have to take this stuff into consideration, okay? Otherwise, it leads to oversizing. We already showed you what that does, okay? So to estimate the pressure drop of the boiler circuit, let's always start with the load. In this case, our load's 10 GPM, okay? I'm going to figure out from the boiler manufacturer's information what that resultant pressure drop is at that given flow. In this case, it's around 2 feet ahead. Even if I add my own pipe out, incidental pipe valves and fittings and stuff, I'm at as little as less than 1 foot, or maybe as high as 3, depending on what components you have in that little circuit. Okay, so let's put it all together. I need a pump at 10 GPM at 5 foot ahead. I introduce you to the 0018E. This is the coolest little pump that's known to man right now in this little category of ECM offering, okay? Notice that we can take this thing and run it anywhere between 4 watts and 44 watts, and that's what makes it real handy for what we're needing to do in this particular case, okay? This shaded area represents anywhere between the 4 and 44 watts. So let's put our criteria in there at 10 gallons a minute and 5 foot ahead. We find our operating point based on the resistance that we estimated of the system, and there's our operating point right there. Okay, so that would give us exactly what we wanted. Okay, if this little pump has 0 to 10 and the boiler was going to send that information, then what it would do is it would coast up and down on that system curve based on the boiler's firing rate. In this case, we're showing you it in a fixed speed application. Okay, same thing goes for a 0015E3. It's not quite as fancy. It's a lot less money than a 0018. Okay, and so let's see where that would do. Let's put the criteria in there at 10 gallons a minute and 5 foot ahead, and we happen to fall right on one of the presets on constant pressure. Okay, just remember, constant pressure is an automatic mode, but it ain't ever gonna move automatically if you have nothing changing hydraulically downstream. And in this application, you wouldn't, so your operating point would be right there at 10 GPM and 5 foot ahead. So there's the 10 GPM at that we needed. What happens when we're not running at a design load condition? Let's just cut it in half. And for the sake of time, I'm going to do the same math for you and do the division by the given GPM to find out what the resultant delta T is. Okay, so that means at half load, I'm going to drop from my 30 that I used at a design condition to half of that, which is a 15-degree delta T. It's not as good, but it's a lot better than the guy that wagged and put a 15-gallon a minute pump in there. So just understand it's very important. Just make sure that initial GPM sizing of that pump is as low as you can possibly get it on ModCon applications. You'll be better off for it. You'll extend the overall system efficiency of that particular job that you're working on. Okay, so it's back to John now. How you like that picture? You haven't seen that in a while, have you?
Oh my God.
Take it away. Take it
a
away.
long time ago in a galaxy far, far away. Hey, Rick, I've got a couple questions for you before we jump in. And
Okay.
I noticed the gentleman's in the audience tonight who sent me an email asking about a specific question, and which you kind of covered, is when, you know, if you have your boiler circulator, right, and that the system flow had dropped, maybe because we've closed some valves, or if we have a variable speed circulator because the circulator slowed down. There's really no way around having reverse flow through those T's, right? It's just
no, as mentioned, like I said,
avoid it.
Right, on those shoulder conditions, you know, when the boiler's nowhere near what it has the capability, and when you're nowhere near what you really needed and you use for the sizing of the pump, you're going to get a little bit of that. The good thing about that, and I've always used this as kind of like, you know, a get away from gotcha kind of thing. Under those shoulder conditions, under those light load conditions, on most of the modulating condensing equipment, you're actually doing an outdoor reset, right? So your actual temperatures that the boiler is trying to achieve is lessened, right? It's lower. So that lower firing rate that's giving you the lower temperature going out to the system, also the result of that is a lower return temperature anyway. So yes, you're going to raise it a bit, but it might be, and most of the time is, under 130 degrees. So you're still going to be in a condensing mode. Again, it could be better, but not everybody's doing the 0 to 10 with a small enough circulator that gives them what they need. And let me emphasize that. When I say small enough circulators, people that got pumps on their boilers, but if you can't ever go with an ECM circulator, you can't ever go lower than low. And if low gives you a real tight delta T anyway, you can't do any better. So a lot of those boilers sit there at their lowest setting and they still have delta T's of 10 and 15 degrees. So it's kind of the same thing. Again, use it if you can. It's more important that I emphasize the fact that size the pump right from the get-go and you'll be better off for the whole season.
Exactly, and the kind of the curveball in here is using variable speed circulators on your distribution side, whether they're delta T or delta P, they're going to slow down at some point, right?
Yes.
It doesn't really matter which one you're using, and you're going to have that almost exact same thing happen regardless. I know we've had a lot of people who don't quite get either can't or won't understand delta T pumping. You know, say that you shouldn't use delta T pumping because in this case something like this will happen, but what they're not understanding is something like this is going to happen regardless. It's
exactly. It happens with delta P as well. Absolutely. And
it'll happen with a fixed speed pump and zone valves. I mean, if you got a lot of zones closing, well, flow is going down. It's just the way it is, you know? Yeah. So as long as you understand it's going to happen, it's not a horrible thing.
Horrible.
Yeah, it's not horrible. It was good. It was, I think, Jeff Suda. I think he sent that email earlier today. And Jeff, I saw that you were attending. So thank you for sending that, because I really wanted to make sure we discussed that tonight, because that is an important thing to understand. That reverse flow is just the nature of the beast. It's going to happen. Our goal is to mitigate the effect, the impact as much as possible. So understanding your distribution pump sizing, which is what we're going to talk about a little bit about next, is a huge part of it. But as Rick just showed, understanding that, you know, understanding how to size the boiler circulator appropriately, and not just throw something in there and say, wow, let's ram the hell out of that water and see what happens. We want to make sure that's done properly as well. So
let me throw something else out. If the boiler manufacturer, I keep saying that, right? Trying to cover our tail. If the boiler manufacturer will allow you to pipe that boiler in series and you do all your little checks of the system, guess what? You don't need to do primary, secondary. Guess what? How can you guarantee the lowest temperature back to the boiler? Guess what? Just bring return into the boiler. You'll always get the lowest temperature, right?
Right.
So this whole thing about primary, secondary, and closely spaced tees and the budding, this whole thing is cool, okay, if you're forced to do it, but not on every job. Okay, so that might be another segment we can do otherwise. So I'll just throw that out there. More food for thought. You don't always need to do primary, secondary if the boiler manufacturer will allow you to do something else. There's other ways of doing things. So go ahead.
Another question came in from Jeff House, and
Who's in the house?
Yeah, Jeff House is in the house. Would a low loss header or a buffer tank mitigate the reverse flow? I'm not entirely sure it would.
No.
The dynamics are still at play.
Maybe a buffer would help because you got the stratification within the tank, and it's a good, keep in mind, buffer tanks, those tall, skinny ones, do the best job of stratification, right? It's a law of physics, right? So what Jeff's talking about, if I can pull off a really cold area, relatively speaking, of the bottom of the tank for those micro zones, then I might be getting lower temperatures, and that might not be coming all the way back down. A little hydraulic separator, what has it got, 1.5 gallons in it?
Yeah.
Depending on your pump sizing, I don't think it would. So.
To me, those are more piping conveniences than anything else. I mean, yeah, they do serve a purpose. I understand that, but the biggest purpose I think they serve is it's a piping convenience.
Yeah.
It's the primary, secondary built for you with a little bit more mass, my opinion.
Yeah.
All right, cool. I think it's time for our trivia question. You guys ready? All right.
Let's rock and roll.
Our trivia question is this. In Monty Python and the Holy Grail, the French knight relentlessly taunted King Arthur and all of his knights of the Round Table. Relentlessly. He said, go away or I shall taunt you a second time. The trivia question, and how you answer the trivia question is you just type it in to the question chat area, and you have until we flip all the cards tonight to do this. That's how you can answer it. The trivia question is, all right, what specifically did the French knight think of Arthur's mother and father? And be specific. Be specific. And the reason I picked this is because of all of the people I know, of all of the people I've met in my lifetime, the French knight reminds me most of Jim De Palma. And if you're out there, Jim, I mean it with love in my heart. But doesn't he look a little bit like him? Dave, you know Jim De Palma, right?
Okay. JD is here tonight. Yes, he is.
All righty, Jim. It reminds me of Jim De Palma. I don't know why. Every time I see the movie, I go, Jimmy De Palma. I just do.
Jim, I'll have to meet you sometime. I'm not sure I can relate.
I just look at the pictures. It's all you need to know. He's right there.
Hey, we got answers coming in.
All right, very good, very good. And we're going to require specificity. Specificity is important. Very good. Come on, Johnny, says Jimmy. Sorry, Jim. Yeah, come on. It's over. Tell me you don't see it. You see this guy in the mirror every day. Tell me you don't see it. All right. Okay, we're going to talk ECM. We're going to start our discussion on ECM circulators. We're going to start talking really just about circulator sizing in general and why you might use these things for your distribution, your heating distribution. ECM circulators are kind of like where ModCon boilers were maybe 10 to 15 years ago. 10 to 15 years ago, who used ModCon boilers? All the cool kids, right? The coolest of the cool used these things, and everybody looked at them like, wow, what are they doing? Are they crazy? Those things are expensive. They're complicated. They're expensive. They got to change everything. I don't know what they're doing, but they were intrigued and they watched the cool kids. And when the cool kids kind of started having more and more success, well, then it started to spread. Now, in any area of the country that is not served by utilities offering rebates, I think you're going to see a lot of the same stuff when it comes to ECM circulators. Who's using them? The cool kids. All right. We did a webinar earlier this morning for a supply house and their customers in Michigan. And unless there were rebates, most of the people just simply didn't use them. And the obvious question is why? Why don't you use them? Oh, they're expensive. but these same guys are putting in ModCon boilers. So the expensive argument doesn't really wash. Now, does it? Yeah, they're more expensive than standard efficiency circulators, but ModCon boilers are more expensive than standard efficiency circulators too. Here's the thing that ties it together for me. Why do people put in high efficiency boilers? Why do they put in ModCon boilers? Well, obviously they want to give their customers the most efficient boiler possible. The price difference has kind of gone away. It's just what you do, right? It's just what you do. Yet we're doing all this work. We're learning how to pipe these things up the right way for peak efficiency, and we're learning about this, and we're learning all this other cool stuff, and we're talking about buffer tanks, and we're talking about hydraulic separators, which all the cool kids are using too, you know, and we'll discuss those things forever. And then our discussion a few weeks ago about water treatment. We're going to treat the water to keep those passages clean for maximum efficiency and longest life of the boiler, and how important that is. And then Kevin Shea told us about, man, combustion analysis isn't an option anymore. You've got to fine tune these things and make sure they're running at peak efficiency, both safely and efficiently and effectively. And we do all that, and then we take a 3-speed pump, set the sucker to high, and go and walk away. I don't understand that because to me, I'm going to give you, to me, that's saying I'm selling you a system, a level 10 system, but this last thing I do, putting a 3-speed pump on there and setting it to high, I'm just derating that system intentionally down to a level 6 or a level 7. That's what's happening. And it's kind of hard to argue that. It really is what's happening. The circulator is probably the most important overall element to system efficiency. Yeah, the boiler makes the heat, right? And we really care about that. We want to pipe that thing up right. We want to make it look good. We want to do all this fantastic work for this boiler. The boiler is the biggest, sexiest, most expensive thing here, and we're going to make sure that's done right. Great. The heat emitters, that's what delivers the heat. That's so important, whether it's radiant floor, panel radiators, baseboard, unit heaters, you name it, anything decorative, whatever, delivering the comfort, that's important too. But understand this, the boiler makes the heat emitters deliver the heat, but the circulator is the thing that facilitates the journey. And how effectively and economically and efficiently it does facilitate that journey is going to determine how efficient the overall system is. And I'm not talking economically in terms of electrical consumption. Okay, that's pennies on the dollar here. What I'm talking about is how close do we get to the correct flow? How close do we get to the right flow to make this collection of parts a system that'll sing and dance, okay? And we define a system. We define a system as something where the whole is greater than the sum of the parts. Okay, it's incomprehensible to me that we put together these systems and then we just slap the pump we always use and, well, let's set it to high because we won't have any problems. Well, no, you won't have any problems. You're not gonna. If you define problem as someone calling you up and claiming they're freezing to death and blaming you, well, no, you're not gonna have a problem. But other problems are gonna come. You're gonna pay that bill. Somebody's gonna pay that bill later on. I'm gonna go on a limb here, and I know my two compatriots are gonna start rolling their eyes. But I think the days of the 3-speed pump are numbered. I think they're numbered because there's the convenience that we bought into of having a little switch that goes low, medium, high. Ooh, how about that? The convenience we bought into isn't worth it. All right, it's not worth it. The convenience is not worth the price that we're paying, not just to buy the pump, not just to run the pump, but the damage it does to the system. So I firmly believe 3-speed circulators are dead pumps walking. It's not going to be long. As the more we understand how these things work, the more we're going to realize these things aren't helping us any. All right, they're great. They're convenience items. They solved a lot of problems, real or imagined, but their days are numbered. I believe that to be true, and that's just because I'm nuts. But hey, let's go there. So let's.
Yeah, you're nuts.
Thank you, Dave. Appreciate that. So let's talk. The reason days are numbered is we have to understand pump curves. We have to understand steep curves, and we have to understand flat curves, and we have to understand system curves. What makes a steep curve and what makes a flat curve? Mostly, a pump curve is steep in relation to another pump, okay? And a flat curve is flat in relation to a steep curve pump. let's just take a look at this. The steeper curve pump is lower flow but higher head in relation to a flat curve pump, which is higher flow and lower head. All right. In the world of pump manufacturing, steep curve pumps are known as European style curves, and they were designed for European style systems. We're talking panel radiators with small dimension pipes, small diameter PEX, and a home run to each radiator from a central manifold with a thermostatic radiator valve designed to a 40-degree delta T. All right, lower flow, a 40-degree delta. If I've got a 100,000 BTU boiler, all right, a 100,000 BTU system at a 20-degree delta T, that's 5 gallons a minute worth of flow rate. At a 40-degree delta T, that's 2.5 gallons a minute worth of flow rate. You run 2.5 gallons a minute, even through, so lower flow, but you're running it through small pipe anyway, that's going to be higher head. Here in the US, we'll have higher flow, but we're going to run it through bigger pipe. It'll be a higher flow, lower head type of system. So steep curve pumps are called European style circulators, and flat curve pumps are called American style circulators. What we did here in the US is when we had our big building boom after World War II, we were installing hydronic systems into homes as they were being built. All right. And we were able to, they were bigger homes, okay, bigger homes, so higher heating loads. We designed to a 20-degree delta T. We had higher flow rates than if we had a 40-degree delta T. But we're installing the system as the house is being built. We installed larger pipe. So we had higher flow and lower head. In European style systems, they didn't have a big building boom after World War II. After World War II, they was picking up, all right, because they hosted the party. What they didn't have a building boom, a new construction building boom in Europe till the 70s, but in the 50s and 60s, they were retrofitting old existing structures with central heating systems, so they didn't have to burn coal and pollute the air. So what they were doing was, by the advent of PEX in the late 60s is really what made this thing happen, is they would do it the easiest way they knew how, and that would be to fish a supply and return through the house to this room, fish another supply and return of small diameter 14 millimeter PEX through the woodwork to this room and to that room and to that room, because it was the easiest way to do it. It's designed to a 40-degree delta T, keep the flow down, even at low flow rates, the really small pipe, you're going to have high head. So steep curves and flat curves were basically, they were, what I say, necessity is the mother of invention. These curves were developed because they were necessary for those types of systems. So I hope that helps a little bit. Why we have steep curve pumps, why we have flat curve pumps. The thing that interacts between both of these are system curves, okay? System curves are important. Every circuit of piping and every system has its own unique system curve. We go through a lot of math, and we did it last week and the week before. We go through a lot of rigmarole, a lot of math to find the flow and the head loss through a piping circuit, through a zone. We do an awful lot of work to figure that out. What that really is it's one point on the system curve plot. I don't know if you guys remember back to 5th grade. You remember doing charts and graphs and stuff and doing these little math formulas to come out with different points on the x-axis and the y-axis and putting them together where they intersect, and then doing a bunch of math, putting all these things on a chart and then connecting the dots and see what you got. Remember thinking to yourself, this is bullshit. I'm never going to use this crap in the real world ever. Well, boys and girls, today's the day, okay? We are going to use this today. Maybe the only time you ever use it, but it's just important to understand what the system curve is and why we care about it. It's really the hydraulic fingerprint of a piping circuit. It could be a single zone. It could be the whole system, all right? It's the hydraulic fingerprint. It is the mathematical correlation between flow and pressure loss. As flow increases in a piping circuit, as flow increases, the pressure loss through that piping circuit increases exponentially, all right? So it's not a straight line. As flow goes up, head shoots up, all right? And the reason we care about the system curve, the only reason we care about the system curve is it's all about the intersection. The reason we care is the system will operate where the system curve intersects the pump curve. Always, always, always. It doesn't matter what kind of pump we're talking about, who makes it, or whether it's a variable speed pump or a fixed speed pump or a 3-speed pump. The system will always work where the system curve intersects the pump performance curve. Happens all the time. So we can go through an awful lot of business to find, 4 gallons a minute at 6 feet ahead. And the minute we slap a circulator on there, it ain't never working at 4 at 6 unless we're really lucky. It's going to work right here where the system curve intersects the pump curve every single time. And if that happens to be 6 gallons a minute at, let's say, 8 feet ahead, well, 4 to 6 gallons a minute, that's only 2 gallons a minute. No, man, that's 50% more flow than we need under design conditions. That's 50% more flow than we need under design conditions. If the flow, and here's the thing, remember our universal hydronics formula. It states that GPM equals BTUH. Let me get all this crap out of here. BTUH divided by delta T times 500, right? We go through a lot of math here to come up with our 20-degree delta T. That's our design, and we came up with 4 GPM, right? And that would be 40,000 BTUs under design conditions, coldest day of the year. Well, screw it. I'm not giving it 4 gallons a minute. I'm giving it 6. Well, the BTU doesn't change. Okay. Oh, I can deliver more heat. Don't need more heat. Okay. We don't need more heat. What's going to happen? What's going to have to give is this. Our delta T, our very best delta T won't be 20. It'll probably be about 12 or 13 degrees. So when the water goes out at 180, comes back at like 168. Or it goes out at 140 and comes back at 128, and we start the whole short cycling dance. So that's the danger of oversizing. And again, that 3-speed pump, the urge to oversize is huge. We go right to contractor no callback mode and get the hell out of there. Nobody calls us to complain that they're cold. We've done a good job, except we've done this. All right. Yep. And we have reduced and intentionally limited the efficiency of the system. And we've also put all of the moving parts on notice that we're going to kill them. All right. We put them on notice that we're going to wear you out ahead of time. We're going to short cycle you into an early grave, and I don't know what's going to go first. It could be the igniter itself. It could be the ignition module. It could be the blower motor. It could be something else. But we're putting you on notice. We're going to kill you. We're going to kill you young, and that's just the way it is. When you short cycle, that's how it works. So it's all about that intersection. That's why you got to know the system curve. You don't need to know. Here's the math formula for figuring out the system curve. I'm going to go over it real quick, but you don't really need to know it because there's an easier way. All right, I'm going to walk through you real quick. So let's say I've got a zone here. I did the math, and my 3 gallons a minute at 6 feet ahead. Now to plot out different points on our system curve, we have head 1 divided by head 2. Now head 1 we know is 6 foot ahead. Head 2 is X. That's what we're trying to find out. Now, again, stuff you thought you'd never use. Let's go back to 6th grade algebra. All right. Flow 1 we know is 3 gallons a minute. Flow 2, we can put in whatever number we want. All right, whatever variable we want. So head 1 divided by head 2 equals flow 1 divided by flow 2 squared. So I know what my head is at 3 gallons a minute. Let's say I want to find out what my head is at 6 gallons a minute. All right. You would think if it's 6 foot ahead at 3 gallons a minute, well, at 6 gallons a minute, it should be 12 foot ahead, right? Not necessarily. So the way we work this out, let's put in the numbers we know. We know head 1 is 6, head 2 is X, flow 1 is 3, flow 2 is 6. So we have 6 divided by X equals 3 divided by 6 squared. So 6 divided by X equals 3 divided by 6 is 0.5 squared. 6 divided by X equals 0.25. Because 0.5 squared is 0.25. Now we want to isolate for X. We're going to multiply both sides by 6. So 6 equals 0.25X. To solve for X, we divide both sides by 0.25, and we will find that the head at 6 gallons a minute is 24 feet, okay? So as flow goes up, head goes up exponentially. That's how that works. Now, you don't need to know this, guys. You really don't. There's an easier way. You need to get yourself a B&G system sizer wheel. All right, this is the B&G system sizer wheel, and use one of the greatest inventions ever. And about 3 feet to my left, I have a copy of the original one, the hand-drawn version of it. I'll show it to you later if you want to see it. But the way you use this on scale number 5 in this white window here, it's a big wheel, adjustable wheel. You align your flow with the head that you know. So I know 3 gallons a minute, and I know 6 feet ahead. Once I have those lined up, all the math is now done for me. If I go this way, I'll find out what the head is at different higher flow rates, And if I go this way, I'll find out what the head is at lower flow rates. So again, I can look at this. All right, 3 gallons a minute at 6 foot ahead. At 4 gallons a minute, it's 11. At 5, it's at 17. At 6, it's at 24. At 7, it's at 33. All right, at 2 gallons a minute, I'm at 2 3/4. At 1 gallon a minute, I'm at 0.7. Okay, so those are the points on my system curve. Okay, so I know them all, right? I know all these points on the system curve. Now, once I know them, I can put them on a pump curve, on the pump curve, a pump performance curve, and see what happens. I can plot out these points. Everything starts at 0, right? And I simply, whoa, excuse me, come on back here. I simply connect the dots. All right, I connect the dots. All right, close enough. We connect the dots, and then we see where this system's actually going to work. Now, if I was a smart guy and I'm looking at this, and I got a 3-speed circulator here, the Taco 0015 standard efficiency, 3 gallons a minute at 6 feet ahead. If I'm a smart guy, I'm looking at this, and I think, wow, 30,000 BTUs, 6 feet ahead is kind of a lot ahead if it's like a fin tube baseboard kind of thing. 30,000 BTUs. I'm looking at low speed here, man. I'm looking at speed 1, and that's going to be a really well-sized circulator. But if you haven't done the math, and if you don't understand intersections, you may look at speed 2. But honestly, you folks put this in. What do you think? Where do you think this thing's going to get set? Everybody, all of you have been out there in homes and you've seen 3-speed circulators installed. You know where this is going to be set, don't you? It's going to be set to speed 3 because A, I don't know the math. B, I'm not sure of the math. C, I don't have time to do the math. So D, I'm going to set it to the one setting I know is going to work and get the hell out of here. It's going to be 3. So if it's speed 3, I'm really going to be working here at about 5 gallons a minute where I need 3. Okay, that's 66% more flow. My delta T's rarely, if ever, going to be in double digits. All right, and I'm going to short cycle like crazy. All right, does that make sense to you? I've been rambling and ranting here for a while, so I'm sure there are some questions. So I want to make sure you guys make sure you get it. Okay. One question I see, Robert Dresser, why doesn't Taco have a scale like that? Well, because it's B&G's. They invented it. It's theirs. And hats off to them,
Yep.
Hats off to them. So that's kind of where that's why we don't, because they invented it and it's theirs. And I have no problem telling people to use it because that's one of the greatest inventions in hydronics history. And Gil Carlson is the godfather of North American hydronics. So anyway, that's kind of where we're at. All right. That's kind of where we're at here. Yeah. And that's how easy it is. That's how easy it is to oversize a circulator. And then all of the things that go along with it. The incredible shrinking delta T limits boiler efficiency, and it shortens the lifespan of moving parts. Other than that, there's no problem. Okay. Other than that, there's no problem. So what does this have to do with variable speed circulators? Well, variable speed circulators aren't on their own going to fix this. It's not one of those things where, hey, I'll put it in and it'll figure it out for itself like magic. What does Rick and Dave, one of the things guys tell us when we ask a group, why do you use variable speed circulators? What's one of the most common responses you get?
For me, in my neck of the woods, rebate.
Rebate, right?
Yeah.
For non-rebate areas, what's the most common answer you get? Well, Rick, what do you see?
Same reason they've moved up to modulating condensing equipment. They're not mandated to do it. They see the value, they see the benefit, and that's why they're using them.
Well, it's interesting because one of the most common responses I get from people is, well, they always give me the right flow. They always give me the right flow. And there's a statement that's about 86% true. All right. That statement is 86% true. To make it 100% true, we need to add 2 words to the end of that. You know what those 2 words are?
Almost never.
Almost never, or hardly ever, right? These things always give me the right flow, hardly ever. It's a circulator, man. It's not a magical thinking thing. It's a pump. It has some brains to it, but the worst thing we've ever called these things are smart pumps, all right? Because they ain't that smart. They do what they do. They do what we tell them to do, really. They just do it automatically. They vary their speed automatically based on input. We have to tell it to do the right stuff. I know a lot of guys, I've heard guys say, whoa, this is the magic pump. You put this thing, it takes the thinking out of it. It does the thinking for you. I've never heard a dumber statement in my life, because they don't do anything like that. Okay. You still are in charge here. They don't replace you. All right. It's not a thinking circulator. It doesn't do the thinking for you or take the thinking out of it. And there's no magic involved. You got to understand what these things do and how they do them. It's very, very important. They're not hard to understand, but they do some pretty cool stuff. All right. They do some pretty cool stuff. All righty. Any questions we have out there, Dave? Any good questions that we need to adjust or need to address?
No, mostly it's just been some comments going on back and forth, calling it a smart pump, yes, and ECM to save energy is the same as putting in a ModCon boiler without an outdoor sensor on it. So from Wineland there, yeah.
So, people say, oh, these things are going to save buttloads of electricity. Well, it's a very small butt. Okay, it's a very, very small butt. If depending on what you pay per kilowatt hour, all right. If you have a circulator running 2,500 hours every heating season, and that's a lot. Okay, 2,500 hours is a lot. Say you're paying 15 cents a kilowatt hour. That pump's going to cost you about $30 a year to run a standard efficiency circulator. But hey, we throw ECM in there, we're going to cut that sucker in half. All right, it's $15. I say $15 over 7 months. All right, that's about $1.50. And what are we going to do with $1.50 a month or $1.25 a month? Go crazy, people. Enjoy. Live large. They can save large percentages of electricity, absolutely. And the marketing department will cite the percentages. A calculator will tell you in terms of electricity, what do they really save? Now, the electrical savings for a small residential ECM circulator, the electrical savings is not to be dismissed, but it's not to be overstated either. Here's what the electrical savings do, or the electrical savings do. The electrical savings does. No, the electrical savings do. Here's what the electrical savings do with a residentially sized ECM circulator is what they do is they make the price difference go away. All right. They make the price difference go away in 2, maybe 3 years tops. All right. Worst case scenario, 2, maybe 3 years. So what that means is, hey, you know what? You don't want to install this circulator because it costs too much. I'll tell you what, your customer's buying this pump anyway. They're paying for it anyway. It's just a matter of whether you give it to them or not. Doesn't matter to me, but they're paying for it. They're paying for it, right? They're going to buy it. It's just a matter of whether you give it to them. And I know when I pay for something, I'd kind of like to get it. I'd kind of like to get it. So it's just the way it is. It's just the way it is. And Wheels is trying to poke me here, and you're trying to get me going, right? Because you and I had this discussion before. Why do a heat loss? A modulating boiler will compensate. Oh boy, I can feel my blood pressure going up right now. Yeah, exactly. It's the same argument as about using an ECM circulator, right?
It's an ECM with a bypass valve.
Oh, don't start with me on the bypass valve. Don't start with me on pressure differential bypass valves. You want me to have a stroke, don't you, Dave?
Not at all, King.
Not at all, King. No, yeah.
That means I become king.
Yeah, that's right. Dave's been plotting this for a while. Pressure differential bypass valve. Oh God. It's a Band-Aid for a self-inflicted wound. End of discussion. End of discussion. So anyway. So, focused, centered. What time is it, guys?
6:02, 7:02, 8:02 your time.
7:02, 8:02. There we go. Well, I've got some more stuff here, but I think we said we'd be with you for an hour, and then start taking your questions. So let's do that. Let's open up some questions here, and let's do some talking. I see Douglas Spector. In the long run, the customer will pay a lot more in boiler service with a non-modulating pump. It's going to pay because he's going to pay a lot more for service with an oversized pump. Absolutely. You still got to know what you're doing with the ECM circulator, and that's something these guys are going to talk about next week. You still got to know what you're doing when you're setting that thing up, because if I just throw in, let's say, a 0015 E3, the Takeo 0015E3 ECM circulator, and I set that to high speed, I'm still working on essentially the same pump curve as speed 3 on what we're looking at here on my screen. It's still basically the same pump curve. So I'm still going at the same flow as I would with a regular circulator. I haven't really done anything other than I'm probably using about half the electricity, which is nice, but it doesn't solve my problem. Knowing that, hey, I may be able to set this down at low speed and work with this thing and have it be a constant pressure, say 5 foot ahead, I know I can do that and make it still work. Now I've really addressed that incredible shrinking delta T. Better yet, if I can use a delta T circulator, a VT2218 variable speed delta T circulator, the circulator that will vary its speed to try to maintain a fixed delta T within the system for as much of the time as it can. Now I've taken that incredible shrinking delta T and I've given it another monumental whack. So I mitigate that even further. So that's where knowing how these things work and understanding how to make them work for you, it's really what's going to separate the professional from the professional handyman. Okay, it's important to know this stuff and to be able to apply these things, because the guys that can apply these circulators appropriately, accurately, and understand what they do and why they do them and really make them work for them, those are the guys that are going to be selling a level 10 system and installing a level 10 system and delivering on that promise. And that's why ECM circulators are so important. Yeah, we can deliver heat without them. We don't need them to make a system quote unquote work, right? But we do if we properly apply them. Now we're delivering on the promise of peak efficiency, long life, and lasting performance, which is really what we started out to do, isn't it? So to me, that's the importance of ECM circulators. It's not about saving a few bucks in electricity. It's about making systems work as well as they can to the very best of our abilities and not believing in magic. So, Dave, you might want to take over. I need a rest. Was that like a soapbox or what?
Yeah, that was a rant and a half.
That was a rant and a half. Well, hey, you know what? It's July. I'm entitled. I haven't had my rant for this month yet.
That's right. That's right.
Dan Cook's got a good one.
What does Mr. Cook have to say?
I ask contractors, how do they know the circulator size properly? And all he gets is crickets. Only one contractor has answered. I measure the delta. Hey, most high efficiency boilers give you the supply temperature and the return temperature, or the contractor can measure the delta T on a cast iron system. If they're close to their desired delta T. Would this be an accurate comment? Absolutely, Dan. One of the things that even back when I was selling boilers is like, hey man, when you're doing the startup of that boiler, one of the things you're doing is commissioning, and one of the things you're doing is you're pushing it into high fire. Again, there's that high fire thing. Take that with kid gloves, but that is the time, once you get everything up and going, everything's purged, everything's full, everything's doing what it's supposed to do, and you're doing the commissioning of that, that's a good time to look at those two temperatures. Look at your delta T and turn the pump down. Okay, we always want to run a pump on high speed for a short period of time to burp the air out of it. It's a wet rotor, but then always turn it down. And that's when, Dan, exactly what you're saying, I agree with, and I applaud you. Let's get everybody singing off the same page.
Well, the other thing you need to pay attention to at that point, though, is what is the outside air temp. So be careful. I mean, if you're starting it up and it's 50 degrees outside and you choke it down and get to a 20-degree temperature drop when it's 50 outside, all right, well, now you might be choking it too much. So you got to take a look at what your delta T, if you had a fixed speed circulator in the system, to make sure it's going to get you. So if your outside design temperature is 0 and you're setting up a system and it's 35 degrees outside, well, now expect a 10-degree delta, not a 20. Yeah,
Dave. You're manually overriding the boiler and forcing it into high fire.
Oh, okay. I got you.
There you go.
Yeah. So
I'm thinking cast iron world.
Yeah. No. All right.
Looks like Sean McGovern looks like he's trying to kill me. How much money does Takeo make selling pressure differential bypass valves? And Dave answered this perfectly. No, none. We don't sell them anymore. We discontinued them. Not to minimize my stress level. Not to minimize my stress level, although it helps. It's simply because they were not a profitable item, because the people. What it is. Okay, here we go. It amazes me how these things became popular, or how they became more common, let's say. And again, I'm a conspiracy theorist in some ways regarding stuff like this, not the other stuff, this stuff like this. I believe when 3-speed circulators first became common, which was about common. I mean, they've been around. I remember putting in B&G Upstarts in my very first house in 1988. All right, and then replacing them in 1989, 1990, 1991. But that's just that particular pump. They really started to become commonplace in about 2002, 2003 with the 1558, and then shortly after the 0015 standard efficiency from Takeo. And people started to say, wow, great pump. This thing solves my pump sizing problems. It doesn't have 1 speed. It doesn't have 2 speeds. You know what? It's got 3 freaking speeds, man. And that's the folks selling them were saying, keep this on the truck for service. It just does everything. So it doesn't matter what you run into. You got 3 pumps in 1. Great. Wholesalers loved it. I can get rid of all of these different SKUs, replace it with 1 pump. It was a great story, largely nonsense, but it was a great story. People started putting these pumps in with zone valve systems, and you had steep pump curves, and they'd put them on speed 3 because, oh, who the hell knew? You know, I got zone valves. That's a lot of, I got to go to speed 3. And what happened? What would happen? They'd bang like hell. Well, how do you stop? You know, then you call up and say, hey, this pump I'm putting in here, I don't know what the hell's going on. I got it on a zone valve job, and these zone valves are banging like hell. Well, what's the response? Oh, well, why didn't you put in a pressure differential bypass valve? Didn't you know you were supposed to put in a pressure differential bypass valve? I mean, that's what you're supposed to do. And very quickly, that became the common installation method. I always do. I use a 3-speed pump and a pressure differential bypass valve because that's the right way to do it. It didn't become. What happened is just illogically, it turned from a Band-Aid for a self-inflicted wound into, well, this is the right way to do a zone valve system. Whereas if you used a flat curve pump like a 007, which had been used for decades with zone valve jobs with 0 noise issues, all of a sudden, because it only had 1 speed and not 3, people said, well, that thing's yesterday's news, man. Even though it was the right pump to use for that application.
Yep.
So that's kind of how, you know, pressure differential bypass valves became, you know, what the cool kids used for a while. And then, you know, then people would say, well, if you compare the price of a 3-speed pump and a pressure differential bypass valve with a variable speed circulator, well, that cost is not, and then that's not the right comparison. I got lost there. Am I done now? Should I go sit in the corner for a few minutes, boys? Are they laughing at me? I can't tell. Are they laughing? Is it good? Are they laughing? But anyway, these are the things I think about, man. These are the things I think about, and I say, and I wonder, how did we get here? How did some of these things that are truly illogical become normal? I don't get it. You know, I just, and then again, that's why I absolutely believe, guys, and you can call me crazy if you want, and you probably will as soon as my back is turned. I think 3-speed pumps are dead pumps walking, man. They're dead. They just don't know it yet.
Well, right now we have a 100-speed pump.
Yeah.
If you like the idea of variable speed, manual setting on fixed speed, Takeo has a 100-speed circulator. So there you are. Yeah, 3 speeds are dead, right? 3 speeds, old news. 100 speed, we've got it.
We've got it. And we've got a way for you to set this thing down to the gnat's whisker too.
Absolutely.
With the 0018E, you only need to know the flow. You don't need to know the head. As Rick was pointing out earlier in his presentation, he figured out the head, but really you didn't even need to know that. You would just have to use the app connected via Bluetooth to the circulator, and then just set that to your 8 gallons a minute or whatever we had. What was it? 12 gallons a minute? 12 gallons a minute. it's going to know that it's 8 feet ahead. All it knows, I got to deliver 12 gallons a minute. And that's what my app is telling me to do. Whatever the head is, I'm going for 12 gallons a minute.
Yeah, understood.
And that size and pump, man. That's the holy grail of pump sizing. Very good. Is the passage about 3/4 inch through the 0015 pump? Is that why the max flow is 31 gallons a minute on the 0015? No, it really has to do with just the speed of the impeller and the hydraulics of the circulator. Rick,
Yep.
you're kind of bouncing around.
No,
That makes sense?
That's good.
Yeah, it's not so much the size of the passage, because you give me something big enough, 3/4 inch, I can cram some flow through it. Give me something big enough. That's what I could do. That's just the capability of the circulator at the RPM that it's doing. So it can do 30 gallons a minute at about a half a foot ahead.
Well, it's going to get you about 18 actually for the 0015.
Right.
Looking at the yeah.
Oh yeah, I'm looking at the other one, the other one here. Yeah, the 0013.
Yeah,
Right.
0013 is going to get you way out there. Yeah, bigger design and stuff like that. Yes.
There you go.
So question right before from Gerald, he's saying it might be a crazy question, but if you have a simple modulating boiler, is there an ECM circ which has external sensors which could max the delta T of the circulator? So we don't necessarily, right now I would say no. There are boiler manufacturers out there working that Rick was talking about earlier today that can deliver a 0 to 10 volt signal to a circulator to tell it what speed to run at, so it gets the desired delta T of that. We have them, and we call those our 00 VV circulators, variable voltage. They are available as a straight AC circulator, not an ECM circulator. Some of our larger circs are starting to come with the 0 to 10 inputs. We don't have it on the small side just yet. So excellent question, Gerald, there.
Hey, can we do this? Let's give the answer to the trivia question. All right, and then we'll cut off. So as of right now, whatever time this is
8:15.
8:15. As of 8:15, no more responses on the trivia question, but we'll get back to the boiler talk. Just don't worry. But what we're going to do is go over the trivia answer, and most of you got this. It's just the thing we're looking is for specificity. Get them in the right order. The trivia answer is, of course, your mother was a hamster and your father smelt of elderberries. Now go away or I shall taunt you a second time. I love that movie. What a great movie. It was 1975. I hadn't seen it. And we had a guy in school. His name was Bob Perica, who was about 6'7". And this was the 70s. He had just hair out and going in every direction. But he's about 6'7", and his best buddy was about 5'3". And what they did was they went to art class, and they made 2 coconuts, okay, out of clay, and baked them in the kiln. And they would walk around school, and Bob, the big 6'8" guy, would do the King Arthur thing. And his buddy had a backpack on and walking behind him with the coconuts going. Dun, 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 dun. And the first time I saw it, I go, what the hell is he doing now? And where was he during lunch break to get imbibed enough to go do this? Then it turned out, oh yeah, that's funny because that's from that Monty Python movie. And I said, Monty Python has a movie? By golly, let's go see it. Then my life changed for the better. So, all right. So your mother was a hamster and your father smelt of elderberries. Very good, very good. All righty. Now, let's get back to business. Where did my questions go? There they are. All right. Where are we at for questions?
Before you go further, I have to give away some stuff.
We got to give away some stuff. We got to do the question from last week, the trivia question from last week. So let me hand it back to Lancelot.
All right.
If I'm Arthur, King and the Britons, and you're Sir Lancelot, who's Dave? Who's Rick?
I'll be the rabbit.
Black Knight. He's the Black Knight.
I think he is Sir Richard of Lorax.
Hey, Richard works.
That's good. All righty. So last week, what did we have? What was our question from last week?
Oh, that was Bruce the Shark. What was the name of the mechanical shark in Jaws?
Oh, that's right. That's right.
And
so
his
these
name
are all
was
winners.
Bruce.
Yeah, so these are our names here from everybody that put in there. So let me tap the wheel and hit the spin. Come on, go, and there we go. I will set up another prize package of a whole bunch of take-o goodies sent out to whoever our winner is. And it looks like it's Albert.
Alberto.
All right, Albert, if you're online, I will be contacting you shortly. If not, I will still be contacting you shortly. Let's see. Albert is here. Yes, I got your email, Albert. So I will send you an email and get your mailing address to send out a prize package. The week before was Jeff House, so I sent that package out. Unfortunately, today, just haven't been out of the house much, so I will be sending that along to you. Excellent.
Yeah, and a lot of you guys had asked about the masks, right? The Takeo masks, right? There's a Takeo on them. I've got a handful to send out, and guys, anybody wants one, just drop me an email, and I'll send you out a couple. So just yes, you guys all have my email address, so it's johbar@takeocomfort.com. Just drop me a line, and we'll send out some, or email Dave. Dave, you still have some too, right?
I've got a couple, but I've been throwing them into the prize packages. So
there you go. I got a few.
That's where my supply went to. So I've got a couple. I think I got to take a look and do the count up on there. So
yeah, I think I got about 12 or so, and some of them are spoke for. But yeah, drop me a note, and if I got to get another one, I'll get you another one too. So that's all cool. So very good, very good. So let's keep this going. What other questions do we have in here, boys?
Well, I'm also going to get into before. Oh, hang on a second, crapola.
Oh, you got next week's presentation. I got to tell you guys, next week you're in for a treat because I'm not going to be here. and to steal a line from Monty Python and the Holy Grail, there was much rejoicing. I'm going to take a badly needed vacation. I need my rest. As you can tell, I need my rest. And that's going to be next week. So Rick and Dave will be manning the ship and probably do such a good job that by the time we're done, you're not going to want to hear from me at all. Don't let John come back.
So yes, yep, it'll be just us two next week. When the cat's away, the mice shall play.
Yeah, I'm gonna have to tune in just to make sure you guys do this right.
I hope you don't. Only for your own sake, right?
Oh, but we'll have the ability to kick him out, so don't worry about it. I'll be paying attention to that.
Yeah, there you go. There you go.
Yeah. Unless he's logging in as somebody else, so then I'll never know.
We got there's one question about the Takeo heat pump. Yeah, that's coming along. ETA, it's not a matter of having product. Right now, it's a matter of how to go to what, how do we want to market this thing, and to whom do we wish to sell it? We're working on an air to water heat pump system where we have an outdoor unit, and then we build an indoor unit, and then it's sold as a package. So we're going to see where that one goes. That's something you'll see next year. I just don't know how or where or when or why. Or no, I know why, but I don't know how or where or when. But it's a pretty cool product. It's kind of well positioned for the future.
Yeah, we've got about 3 or 4 of them out there running right now in a couple of beta sites. I'm looking at one hopefully showing up here in New York real soon, so I'll be able to play around with it a little bit more and see what's going on there. We got one in Connecticut, we got one up in Canada, in Toronto right now, so a couple more floating around there just to do our beta sites. So. Saw another question come in a while ago from Steve Racy. He says he works on a lot of older systems with existing cast iron rads. Are the ECM circs susceptible to metal and rust floating in the water? And the short answer to that is yes. All right. The second part of the answer is it depends on which ECM you drop in there. One of the things that we've done with our ECM circulators we have what we call a bio barrier, black iron oxide. And I actually have a cartridge sitting right here. So here you go. You're taking a look at that cartridge, and what you see right in the back here is this brass mesh. And that brass mesh is going to prevent any of that metal, rust, black iron oxide from getting into the cartridge and getting to the magnet, because this is the part that's the magnet for you there. So when a cartridge fills up with water, it fills up with water on day one. It doesn't flush it and bring new water back in again. So it's not constantly moving back and forth. It's just water that's in there. The only time water leaves a cartridge is when you drain the system down, you drop the pressure down. So we're not constantly flowing water back in and out all the time. So it's just that day one water that you put in there. But if you are working on a lot of existing cast iron rads in your systems out there, maybe it is considered not just for the circulator, but also for the system itself to clean it, to put in magnetic dirt separators. If you're just replacing a pump and putting an ECM in, I'm not telling you have to put in a dirt separator, magnetic dirt separator, but it's never a bad idea either.
Speaking of magnetic dirt separators, here's one. This is the Taco magnetic dirt separator. And it's what it is. It doesn't have a lot of bells and whistles. It's pretty straightforward and simple. All right. It looks a lot like our 4900 series air separator, which you would be correct in saying that, except that it is upside down and it has a magnet. Yeah, there's the 4900 series air separator. Here's its brother or cousin, I guess, the dirt mag separator. Same idea. We got Paul rings in here, and instead of the Paul rings acting as a coalescent medium to get all these mini micro bubbles and mini micro bubbles to glom onto them and then go glug 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 out the vent, what this is actually working as it's working as like a collision medium. So all that crap, that metal flakes and all those other gooky stuff that's flowing through the system, coming back to the boiler. Always put these things on the return, coming back to the boiler. Well, the Paul rings act as a collision medium. All right, so as the things hit the Paul rings, they kind of stop, and then this rather small but remarkably powerful little magnet, which is just clipped on the bottom right here, will just yank them down into the lower portion of the separator and hold them there. All right, this is a little magnet. It doesn't have a lot of pull strength, but it has it's incredibly powerful in terms of Gauss. All right, write that down, people. Gauss.
I like it. Say it again.
G-A-U-S-S. Gauss. This is a 13,000 Gauss magnet, and I don't care who you are, that's a crap ton of Gauss. All right. Gauss is a measure of a magnetic field's strength. It's not pull strength. I mean, like, remember the old monster magnet when we were kids? That thing had pull strength. I don't know what it had for Gauss, but it had pull strength. This is just a magnetic field, and what it does is it's kind of going like this, and it's pulling those things down and holding it in solution. You'll reach a point where you'll turn the circulator off, stop the flow, and then you make a connection down below, or you put a hose on here, open this thing out and open this valve up and just blow the crap right out. Okay, it's a very simple magnetic dirt separator. There are fancier ones out there with this big old pull magnet that you yank out and you can see all this crap on it, and it's actually kind of neat looking. What you're after here is simple and straightforward, and that's what you have with the mag dirt separator. So it's just simple and straightforward. You don't have to get real fancy here. There. Now, you did discuss the shake, rattle, and roll and the
not tonight, no.
Short start. Why don't you show short start? Since that question came up, do you want to show short start tonight, or do you want to wait till next week?
Yeah, I can do that tonight. That's not a problem.
Mike kind of set it up, so you kind of have to now, Dave.
Yeah. I know, right? No, don't show us. Keep us in suspense. But I also want to bring
you'll probably have to show it next week as well anyway, but go ahead.
That's fine. Also about that barrier in there, just to let you know, when I said a short answer of yes, not all circs have that in there. All right. So when you start looking at a lot of other ECM circulators, they don't have that bio barrier in there. So if you are dropping in another circulator that may not be green, you might need to consider magnetic dirt separation automatically, because that circ can seize up rather quickly. I've seen them seize up in about in one season, especially here in the Northeast. I had a lot happen. Mark, you said you had one die because someone took the cartridge pointing up at the ceiling. Yes, ECM circulators, we still want that cartridge horizontal. All right, just like an AC circulator. So we still want to see those things going on the horizontal plane with the motor. So take that motor, follow the horizontal, because you still get that air, could still get stuck in the top of the cartridge and not lubricating and cool out that bearing. So yes. So what John was just talking about with Sure Start. So in our circulators, we've also built in automatic correction features built in. And you know, if you had a circulator die a premature death, it's going to die for one of two reasons. One, it's going to get airbound, or two, it's going to seize up and not spin. So that's normal. That's what happens when they die prematurely, other than lasting, say, that 18 years that we estimate 250,000 cycles of circulator to go for. So in the ECM world, what we did is put this sure start in, which is going to automatically fix one of those errors or both of them that may occur in a system. It's nothing that you can do yourself. It's just going to do it on its own. So I took a circulator and I just took the motor off of it, and you'll see here I've got a line cord on it. I threw a switch on the front side just to make my life easier. And if I turn this thing on, it's going to be airbound. Now, if you know now this is not going to purge your system. It is just purging any air that might be stuck in the circulator itself. Because we need to have that air removed out of the casing, this thing doesn't pump air. It's going to pump water. It's got to move water around. So we want to get the air out of here and send it out to the system, send it back to the air elimination you have in the system. So I'm going to turn the circulator on, and we're running. We're completely airbound right now. And what you're going to see on the front side is that you'll see the operating light, and then you'll see a quick flashing white light. Now, what you can't tell, but I can feel it in my hands right now. When you see that white flashing, it's trying to get the air out. Now, if you had air stuck on a circulator, how would you get it out? Maybe you've got a check valve in there. How do you get the air out of that circulator? The first thing I know what you're going to do is find the closest valve you have and get your hand on there and start jamming it quickly. Open and close, open and close. Change the pressure differential around that circulator to try and just shake that air bubble out and send it to the system. So I know I used to do it all the time working on radiant floor systems, because you'd see the air bubble in the PEX right next to the circulator itself. So you're trying to get it out, and you're just opening and closing the valve to change that pressure real fast to try to move that around. When you see this flashing light, the circulator is doing the same thing as that valve. It just quickly drops its pressure, the speed. So I can feel a quick drop in speed by holding it here, and it's just changing that pressure differential to try to move it around into the system and get it out. It's going to sit here and do it indefinitely, trying to get the air out. Now, this one here, if I were to leave this running for the next, say, 40 minutes on my desk, the motor gets hot. Once that motor gets hot, then you're going to see that light's going to change to red, solid, and the circulator shuts off. Thermal impedance protection built in says, hey, I don't want to burn out. So I'm just going to shut down. You have to do some purging. You got to get the air out of here because I can't move a thing. I went to a job site once that had the circulator was actually half filled with water, and they couldn't get it to work whatsoever. It's not going to purge. All right, it's going to get those air bubbles out that get stuck in there. This system had no pressure in the system whatsoever. It just had a little bit of water, and they wanted to know why it wasn't moving water. And I could actually see the water stain inside the circulator because it was a horizontal pumping system. So, all right, let me turn that off. In order to reset it, let's say you did come back to the system, you find out, I got to purge a little bit more. Let me get some air out of here. Turn the power off, turn it back on. All right, it'll reset itself. You'll get rid of the red mode. So this way it's not a dead circulator. So now here, seized circulators. And seized circulators you're going to find most often in the summer, or that full startup, right? Or a solder ball gets in there. The tolerance between an impeller and your casing is really close. And as your circulators get older and older and they sit for the whole summer, yeah, we try to put a coating on the inside of the casing on the cast iron. But once you get to that long life out of them, that 15, 16, 17 years, yeah, that coating might be rusting away. And now that tolerance between your impeller and the casing could actually start rusting the two together. And if anybody here has ever run into a seized circulator, how do you fix it? What's the first thing you do? Please tell me. Type it in there. All right. I know what's going to happen. And I know what I want you to do. It doesn't say it in the instructions of any of our circulators. All right. But if you find a circulator, it's screaming hot when you walk down there, not moving any water. All right. What's the first thing you're going to do to it? You hit it with whatever. Yeah, that's right, Bill. Whatever tool you have in your hand, you whack it. Yeah, you got a screwdriver, you got a wrench. What's that?
Dan
the
Cook
BFH?
BFH.
Yes. Yeah, or you turn it on and off. You're trying to turn it on and off by Samuel saying that there. Yeah, because you're trying to get jar to it to start going. Actually hit it with whatever you got to break up whatever's holding it in place, may make it work. So I'm going to put my hand on the circulator. I'm going to hold this impeller down from spinning. So I'm clamping it so it doesn't spin, and turn it back on again. And here you're going to see the circulator. You're going to see the light on the circulator. It's going to try and run. It ain't going anywhere. The light's going to flash red, then flash white. And what it's doing there is it's acting like a hammer. The flashing white shakes it back and forth quickly. All right, and then once it goes back to the blue, the normal operating mode, it's going up to almost 5,000 RPM. And you could probably hear it. I think you can hear it, right? So here it is. There's the shake.
There it is.
That's up to the 5,000 RPM. Stop. And then back up to the 5,000 RPM. All right, this is going to happen. Can't hold it forever. That's going to happen for about 20 minutes in your system. After 20 minutes, if it doesn't clear, then the circulator shuts off. Red light comes on and says, hey, you got to come fix me. I can't clear it myself. But it's not going to be a dead circulator, so you don't have to replace it. You just got to get that out, or whatever's holding it up there at that point. So these are going to make the circulators last a heck of a lot longer, and also eliminate those nuisance calls that you have. You won't even know what happens. The homeowner's not going to know. Typically, the air purge or the short start and shaking back and forth, it fixes itself in the first minute, 45 seconds or so that we've experienced, and nobody even knows it happened.
Yeah, it
Now, the
solves
only
the
time
problem before anybody knows there is one.
Right. So especially those systems that are sitting off all summer long like they are now, then we can just jump right past it. Yep.
Yeah, and when you start looking at things with we were talking about cost earlier, all right? Yeah, these things are going to be more expensive, and let's put the rebate states aside, because in rebate states there's no decision to be made here. If the utility's giving you $100 off that pump right at the counter, or $75 or $50 or whatever it is, there's no price decision to be made here, right? It's just like, well, duh, let's do it. In areas where, and let us know if you are in a non-rebate area where you have to make a decision. Do I buy a 007 or a 0015 standard efficiency or whatever pump you might be using, or do I decide to spend an extra whatever it is, 20, 30, $40 for a 0015 E3? Okay, if you are trying to make that decision, what are some of the things that you would factor into that decision? Well, one of them has got to be this. When do circulators, when do volutes get airbound, Dave and Rick? When do you see, when you see one of these things get airbound, when does it usually happen?
When they don't know how to do a good purging, the initial startup of the system.
Initial startup of the system, or whenever somebody works on the system and has to open it up, right?
Yep.
And almost automatically that shows up a day or so later, right? And then you got to go back and try and fix it, and you can't charge for that. You were the last person there. That's 2.5 hours out of your day that you were planning to get paid for and to bill out that you now can't. Okay, right there, price difference is gone as far as I'm concerned. Price difference is gone right there. The short start, when you have to go back and you whack it with a hammer and spend 10 minutes downstairs trying to figure it out, and then charge for the service call, and you go, what'd you do? You just hit it with a hammer. My God. Try having that rather uncomfortable discussion. Well, now we don't have to do that. We freed up time to be able to do more profitable work. Price difference starts to go away. Some of the other things, I think some of the stuff we talked about this morning, Dave, when it comes to the circulator, we've got the four-way flange, right? Do you have one handy there, Dave? Show the four-way flange on these things makes your life very easy. Doesn't matter, as a replacement pump, doesn't matter which way the flange sets are going on the existing system. This will fit one way or the other. Doesn't matter. Okay, so you have that ability to set it up. You also have what we call nut grabbers, which are fun to use and fun to say. But what these nut grabbers are, it's a fine machine milling. There you go. That allows you to use the circulator use the flange as a wrench. So you can put these things in with two hands and one wrench, as opposed to 3 hands and 2 wrenches. All right. And the fact that it's precision milled makes a difference, because a lot of this isn't a new idea. A lot of them are actually cast. You see them in flanges where they're actually cast into the flange, but the casting is rounded, and sometimes that nut doesn't fit very snugly, all right, or very well. This is a precision milling, so it fits in perfectly. It's, again, just designed to make your life a little bit simpler. And then hold it in your palm like that, Dave.
Yep. Well, before you go any further too, and I've had the phone call on this where they say, oh, it was machined wrong, it's spinning. All right. That means somebody put in the bolt, because you got to remember, it's not a bolt grabber, it's a nut grabber.
It's
Two different sizes.
Thank you.
Got to take it out, spin it around, put it in. Okay. Then you're good to go. Yes.
It's a nut grabber, not a bolt
Not
grabber.
a bolt grabber.
Very
Yes.
good.
Yes. So,
And the other thing is, holding the palm of your hand. Look at that. Look at what he's doing. What's that? What is that circulator not doing? No, it's not flopping over, right? Any other
Yep.
Yeah, any other circulator, if you put it on, mounted it on a flange and you're getting ready to put it, you got to hold it in place while you try to thread everything else and connect the nuts and bolts and stuff. This thing, because it's not back weighted, it's more balanced, it's just going to sit there. And again, it's a little thing. It may not matter to anybody, but it might matter to somebody, where you can now, again, put this together with 2 hands and 1 wrench instead of 3 hands and 2 wrenches. Little stuff like that might make a big difference in how these things go together. Question about the gaskets on that,
Yes.
Dave. What about the gaskets?
Yeah. Well, I mean, right now the circulators, they come with all the ring gaskets, or what I call the square rounds, right? I prefer the square rounds, but remember this, you do not need to put a lot of pressure on tightening these things down.
Mm-mm.
All right. You do not. We're not looking at a lot. I mean, it's get them touch and then maybe 1 turn of your wrench, and that is it. All right. But make sure you're not over tightening one side versus the other. That's what ends up happening, is that somebody tightens down one side and they can't get the same amount of turns on the other. So you start putting forces all in the wrong direction. Tighten them both down by hand. All right. And then maybe 1 turn on both sides and you're done.
So you don't need the
It's not
4-foot
a lot.
wrench and the 3-foot cheater bar.
Not at all. Not at all. And if you've got the grooves in it, like this one here has got the grooves, that's going to accept your square rounds in there, throw the square rounds in and rock and roll. When you have the flat gaskets, again, you got to make sure they've got a lot of sealing points, right? Flat gaskets here, it only really has this little ring right here on the inside, all right, to really seal on. So the square rounds, because they compress, they're softer. Don't force a lot in there. Don't force it.
Just a couple of other little things, and this is why that price difference starts to go away when you start to really think about the little stuff. Wiring. This is what we call a double insulated motor, meaning the composite casing is injection molded over the motor itself. That means you don't need a wire. You don't need a ground wire. So instead of 3 wires, there's only 2. No ground wires needed here, so there's no ground screw. And you know why they call these things ground screws, right, Rick?
Go ahead, because they fall on the ground.
They wind up on the ground 99 times out of 99, right? So there's no need
twist
for
done. Yeah,
one twist
usually
done.
it usually hits the toe of your boot and then under the boiler, and you're gone.
Under the boiler, and then we're done for. Then you just snip off the ground wire and say, I know nothing, right?
Yeah, I didn't see it. Yeah. So, yeah, when you see the circulator here, so so this portion, the black part that you see between the 2 fingers, that's the motor. That's it. All right. In here, inside the green portion here, is a big old air cavity, and there's a circuit board that's in here that's actually now telling the circulator what to do. So that circuit board is sitting in here. So that's why all the weight is really just here in the black part, and then the casing itself. So that's why it ends up being a little bit more balanced. But that, we do the motor part, and then we do the injection mold around it. So therefore, you're not finding that ground screw. So we've got a big old box with plenty of room inside there for you. And there's no capacitor either. No big capacitor. An ECM circulator already has a higher starting torque than a standard AC circulator with that big old capacitor built on board. So you don't need it. The other thing about an ECM circulator is that it's, and probably stealing some thunder from next week, I don't know. Oh no, Rick is sizing circ, so I don't know if we're going over the anatomy, but they also run cooler than your standard AC circulator. So you're not going to feel that heat that you have in the past on your standard AC circulators.
Now, I noticed something interesting about those 2 wire leads that you were showing there for a minute there, Dave. What's the deal with those 2 little wire leads?
Look what color's not there.
What color's not there?
Yellow.
Yellow.
You ever get a new electrician on a job site and you ask him to wire up the circulator, he doesn't know what the hell to do with a yellow wire. He sees the black and he sees the yellow, and what do I do with yellow? Oh, it's white. Really? Yeah. So
And
now we
the-
made it easier for the Sparkies out there. So now we
So,
give you the
and
white.
you've got
white
6-inch
and black
stranded.
now.
You got 6-inch stranded leads, so you've got a little bit of room out there. But what if you needed more room for wiring?
So just grab those wires out, do the wiring where it seems fit, okay, and then put it back in. That Molex plug is only going in one direction, so you're not going in backwards.
I was showing this to a contractor in Minneapolis a few years ago, and we were talking about all the little different things, and he said, and go, yeah, whoopee, yeah, whoopee, yeah, whoopee. And then I showed him that little plug, and it says, and it makes your wiring easier. So you got 6-inch stranded leads, so you don't have to wrestle within the junction box to try to wire, where everybody's got big old fingers and you can't really get in there. You can do the wire nut work out here and put him in. And all of a sudden he kind of leaned forward like he was interested. It's the first thing I said that actually mattered to him. I said, and if that's not enough room for you, pop this thing out. You can do the wiring out here and then put it back in. And he looked like he wet himself. He was so excited. And he said, send me a pallet. That was the easiest sale in the world. He saw that, perfect. He wanted a pallet of them for his cruise. And you never know what's gonna float somebody's boat, so to speak. So it was kind of neat. It was kind of neat. And do you have the 0034E right behind you? Is that, again, stealing from next week, Rick, or do you want to show that real quick?
Yeah, I'd be glad to show it. Yeah.
No. This is the big brother of the 0015E3 and the 0018. This is the 0034E.
E plus, that one there.
E plus. So we're up to 34 feet ahead, and it goes out to how many gallons per minute? That's about 50 gallons a minute.
Look at the size of the impeller and the volute for the impeller there. Look how that, remember, this is an engineered casing. We engineer the casing to do the delivery of the GPM that's needed for the particular pump's capability. So anyway, very cool.
Yeah.
So I still have to install this. I'm going to take out a 0018E and put this in. I'll wait till fall to do it because none of my telestats are opening or anything right now, and I want to run it against a dead head. So
there you go. So again, that we've got ECM up from a very small 006E for domestic hot water recirculation all the way up to the 0034E, and then you get into our VR15s and VR30s for light commercial applications, and then ECM and a high efficiency for our larger commercial pumps as well. So it's been an interesting journey, but we have, residentially anyway, we have about the widest ECM offering that there is in the business.
I like to say from 3 to 300 gallons a minute.
We got you
ECM.
covered.
Yeah.
We got you covered. There you go. There you go. How many do you need? We got them all. All righty. Well, great. Hey guys, what else do you have for questions? We've been pontificating here for a while. So what other questions might we have? We had one advantage of an indirect hot water tank added to a boiler system is that it exercises the system all year long. Very good. Yeah, that's good for the circulators. Absolutely. Absolutely. And one burner instead of two has always been an interesting advantage in my book anyway. The guys that sell the tankless will say, yeah, but why do you want to keep 40 gallons worth of hot water or 60 gallons worth of hot water hot all the time? That's just, why don't you just heat it up as you need it, which is a compelling argument. So depends on what you need. If you got to fill a big old hot tub, good to have some storage, right?
Well, these things are down to like only losing a quarter of a degree an hour.
Yeah.
So you get a lot of standstill time without cycling all night long or anything. So again, my vote, unless you've got a condo, or excuse me, like a cabin or something that you're never at and you only go to occasionally, I'm a fan of storage. That's just me.
Yep. And there's different applications. If it's just showers, or just it's not a huge, you don't have a real draw. All right. You got your basic kitchen sink and a couple of bathrooms. All right, maybe a tankless makes some sense. Yeah, we'll see. It's just there's Dan Cook's now your new big fan though. He just said Rick Mayo for president.
Thanks, Dan. Yeah.
There. And then yeah, we got a couple questions. Mark Sheen asked, "What's the best wall-mounted gas water heater?" Kind of out of our bailiwick, and I don't know enough to make a recommendation like that. To be honest, maybe someone else can chime in on what you guys use and share that with Mark. But like I said, I don't really want to. I don't want to make a recommendation because, like I said, I don't know enough about them I know enough to be dangerous. All right.
I mean, if you put, you know what, I used to get that all the time back in the day. What boiler would you put in this house? What would you do here? What would you do there? Go with what you have, the most amount of experience with and or support locally to you, meaning your wholesaler and your rep agencies. All right, and take advantage of those relationships. And ask them, what are you selling the most of, and what are you getting the most returns of or problems with? So in your area, so this way you can get parts, you can get service, you can get help. The biggest thing, that's what I find. Whatever you're going to get the most service out of, just like Dan. There you go, Dan. Same idea. Yep. You want to be able to service it. You need to be able to work on it, and also make sure they got parts if you need parts, because stuff breaks. All right. Everybody says things nowadays, they all suck. You stand at the counter, you're talking to guys, and oh well, that brand sucks. There's no true product out there, in my opinion, that truly sucks.
No.
A lot of times it may be a lot of misapplications, misapplied, or maybe even the instructions suck, but maybe the product doesn't. So, and it doesn't have a lot of clarity into it. So one of the things that Rick said earlier today, right? RTFM, all right, got to pay attention to that, and therefore maybe things don't suck.
Yeah, there you go.
So, yeah,
I can remember back when we were all graduates of the Worsbo School of Hydronics. We all spent many years working for Worsbo / Uponor. But I can remember doing a class once where guys would say, "Well, what product's best? Why should I use your product? What and whatever." And then this one guy from Indiana came and he had an agenda. He wanted to yell at me because he couldn't get our product anywhere nearby him. And then why should I use your product? I said, well, if you can't get our product anywhere near you, you shouldn't use our product. I mean, you can't. I mean, I don't know what the discussion is. I mean, one of the best abilities is availability, right? It's all a matter of that. What's that chain like of support at the wholesaler, support from a salesman, support from the rep, and support from the factory, and everybody in between. What's that chain like? And it's not just the product, it's the chain, right? Because there's no bad products out there. Dave and Rick both said there's no bad products out there. Nobody making junk. It's
Good
what's
stuff.
the chain like? What is the chain like? Who is helping you out here? Who has the stuff that the literature that you can read to learn. Whether there's training available. All those other things are part of the equation to help you decide what product to use, regardless of it. And only this guy was really mad. He said, I'm so mad I can't get your product. And I said, then you can't use it. I mean, I can't instantly go down there and tell someone to sell it to you. If you don't have someone available to you, well, then your decision in the short term is easy. Longer term, we'll see if we can't open somebody up. But in the short term, you got work to do. You got to do what you got to do. If it's available, go for it. And you may find that if you use that product and it works fine for you, then you'd have no need for our product, and that's fine too. That's you got to make the best decision for you, not the best decision for me as the representative of the company. So it was interesting. Here's Douglas Speck says, the question we hear at the counter from contractors convinced me that nobody reads the instruction. They just gripe if it doesn't work right. I'm shocked, actually shocked. I'm shocked to learn that gambling's been going on in this institution. It's a guy thing. Men don't read directions. Men don't ask directions, and men don't read instructions. It's just the way it is.
Only when it's not working, then do we open up the instruction book.
Yeah. If we can't reach anybody on the phone. Yeah.
Jay King's got an interesting one here, and I might have to clarify his question. What about an ECM circulator to reduce flue gas condensation on a converted gravity system and you have a cast iron or steel boiler? Jay, I think I understand that we can take a VT2218 and use it as a shunt pump to keep the higher temperature what we do is we pull out of the supply, push back into the return to maintain a minimum return temperature to avoid sustained flue gas condensation. I think that's where you're going, and I guess I should clarify that. So
Yeah, I think when you talk about piping in a boiler bypass and using the VT2218 as a set point pump and the shunt pump to maintain a minimum temperature, I think if that's what you're asking.
Yeah, I would explore as to why we're seeing such a low return temperature coming back to that boiler too. And I'm going to assume if it's an old old converted gravity system, you've got some large volume of water in the system too that you need to move around. And it's taking a long time for that boiler to get up to temperature because of that large volume of water, the large pipe that you have, all that cast iron pipe, all the cast iron they take heating up, and that goes into sometimes also boiler sizing. So when that system was first installed, all right, the pickup and allowance factor of the boilers was around a 40%. All right, so if you had a heat loss on a system that only needed to deliver, say, 60,000 BTUs, the 40% pickup factor made you put in a boiler that had 100,000 BTUs. Today's boilers, that pickup factor is around 15%. So now you had that 60,000 BTU load. You put in a boiler that's only got 75,000. So you're it's going to take a long time for that boiler. If it's a cast iron boiler, like you said, it's going to take a while to get up to temperature. So what Rick and John were talking about is also making sure you get that return temperature up higher. So putting in a bypass line has been a, so to speak, correction a lot of people have done. They just connect the supply return and they put a ball valve in the middle. Well, that's an uncontrolled bypass. You have no idea what flow is getting and what temperature is coming back. So if you put a circulator on that bypass, now you've got control over it, and the Delta T circulator would have control to prevent it from condensing. If that's where you're going, Jay. Yeah.
Yeah. Let us know that answers your question, Jay. Good question. Okay, here we go. And from Nick Sorrento. Going back to Delta T, is there a good device or system to do long-term logging of a furnace's running parameters, temperature, cycle, and zone calls? And more important, is it worth trying to track these things? Depends on how much of a data freak you are. I guess there are people that love data and want to know a little bit of everything. And that's okay. It's just a matter of what are you going to do with the data. What are you going to do with this information once you have it? A lot of the ModCon boilers and Wheels and Jason, if you're here, please chime in if the NTI boilers have this as well. A lot of boilers have in their control will keep a running tally of total run hours. How many hours since this thing was installed? How many hours has it run? Has it been on? And then it'll tell you the number of cycles. Jason says, yeah, the NTI boilers have that as well. Excellent. And then it tells you the number of cycles. And a little bit of math then there can tell you what the average cycle time is. Our friend Anthony Reichow told us this story about going to troubleshoot a boiler system that just something was weird going on. And I don't know what they were actually there looking at, but then they decided to check the control just as part of the process. And they saw the number of run hours and the number of cycles, and it seemed to be a bizarre ratio. So we did a little bit of math and found out that the average burn time of this boiler, the average run time of this boiler for the past year, the first year that it was in, was about 13 seconds, which is freaking nuts. A boiler didn't have time to get efficient, and it only runs 13 seconds. So nobody froze to death, but that boiler wasn't efficient, my friends. That was not an efficient system. And that was one of those things that, okay, let's now figure out why this thing is running for 13 seconds, okay, and only 13 seconds. And it wound up being a combination of things, but, the oversized pumping was a big part of it. So, you've got to, that's the value of the data. The data itself doesn't mean anything. It's what does the data tell us? And in this case, having that control with that information allowed them to do some pretty quick math and say, hey, whoa, that's goofy. And they wound up being able to take care of it. So that's kind of where The boiler will tell you a lot. The wheels are saying that their control for the NTI will tell you run time, call time, and burn time, which are all all good things to know. All good things to know. And our 0018E circulator, which Dave's going to show you, Dave and Rick are going to show you guys next week. The app itself will be able to tell you the cumulative amount of run hours, how many hours has that circulator been running since it was installed, and it'll also tell you the number of cycles or shutdowns. So then it's kind of the same thing. I mean, did we oversize this circulator? Did we set this thing up right? If I have a lot of cycles and they're not very long, maybe I've got this thing sized to set up to go too fast. So again, that kind of data can tell you good stuff if you know what to do with it. Otherwise, it's just numbers.
I mean, I've heard of a few companies out there that are making some data packages, some control packages that you can add onto a boiler and gets the whole system online. And the product isn't, I can't remember the name of the product, so I have no idea. I've had conversations with people, and if I remember, somebody in Southern Illinois was making some stuff out there, and guys were using it, and it's pretty cool stuff, but yeah, like John said, you got to use the data, got to do something with it. And Rick and I had some experience with projects with control systems that did a lot of stuff for you. It told you everything. And it was pretty cool for freaks like us. For the general consumption, for the general public out there, it was just like, yeah, I don't need to know that. Yeah, you can do it, but just because you can doesn't mean you should. In some instances,
Yeah.
I mean, so it was pretty cool. I got used to it because I had it in my own house, but then once I took it out and I moved and put in the new house with the new system, I kind of missed it. But then I got used to it again because it was just like, all right, I was just overrunning my brain with data that didn't need to. Well, the water temperature says it's 141 degrees. It should be 142. Damn it, I got to go figure out what's going on. Now I was starting to get that crazy with it. So yeah, you can get a lot of data, and it's going to help you out with it. But I think what we see out of the boilers today, and just looking at it and whipping out a temperature sensor is going to tell us a lot too, and the math behind it too. So a lot of these controls that are monitoring it is just doing the math for you also.
Yeah. Here's not a question, but an observation from Roger Cunningham. Had a lot of problems with folk not doing heat loads and just taking the old boiler size and installing the same size for the new boiler, causing the new boiler to short cycle, etc. Boy, there's another chronic problem. I mean, and I look at stuff like this, and it's like, you feel like you're constantly pushing, like you're Sisyphus and pushing that rock up the hill, and you almost get it up there, and bam, it rolls back down again. And thank you for noticing my allusion to Greek mythology. I just want you to know I'm an educated man. Anyway, it's late, and that's going to happen, and there's no way to stop that from happening. The thing that I think, the best thing an individual salesperson or an individual contractor can do is basically put his stake in the ground and say, that's not me. I'm not going to do that. I'm going to do this the right way, and I'm going to make sure my customers understand what I'm doing and why I'm doing it, and be able to express the value and what it is what I bring to the table. You can't change the world, but you can change that one guy you're talking to across the table. You can express to that customer the value of what it is you're doing compared to what these other guys are doing, just throwing in a boiler and saying the hell with it. That's really the only thing you can do. I had a conversation with my son just the other day, and I said, in this world, there's only two things you can control: your attitude and your thoughts. Your attitude and your effort, rather. You can control your attitude, you can control your effort. Everything else is left to chance. But those are the two things you can control, and you can't control anybody else. So in this case, a lot of guys say, why would I bother doing this? No one else is doing it, and they're just cheap, and it's frustrating. I get it. It is really frustrating. But all you can do is control your attitude and control your energy and effort, and then focus it in the right direction. There. Okay.
There you go. And Doug said a great point there. You know, if you're going through the effort and time to replace the boiler for a customer, why not just go a little further and do it right?
Yeah, they're spending an awful lot of money, you know.
Do the load calculation, and I understand the other side of the story too, because homeowners are going to say, "Wow, that's a lot smaller than what was in there. Is it going to work?" I mean, and if you go back to the, you know, if you were a contractor in the 70s and 80s replacing circulators, right? What was the circulator of choice on hydronic systems back in the 70s, right? You saw your B and G 100s, your Takeo 110s, and then all of a sudden you came along and Takeo came along and said, "Hey, by the way, here's this nice little 007 that's going to do the same job." All right. Homeowners looked at it, contractors looked at it, said, "Nope, not going to do it." You know? No way that's going to heat my house. So it is an education part too at the same time, saying, you know, that boiler was oversized. If it ever shut off in the middle of the winter, it was too big. You know, when you hit that design day and if it shut off, if it only ran for a couple of minutes each time, it was too big. So, and of course also, and I think that's also our downside. You know, we don't want to talk to our customers. We just want to do the job and get out, right? We want to get in there, get it done, get out and move along to the next project. So we got to talk to them a little bit and explain to them. They have no idea what we're doing. No idea. Terrified. When we stop and think about it, if a boiler system is going to cost a homeowner $10,000, that's a lot of cash just to give off to somebody that I just met.
Yeah.
Right.
They're taking a second out on their mortgage to do that. Not everybody has 10 grand, right? So
yeah. So we got to talk to them on why. So spend a couple of minutes and do the heat load and figure out what size boiler is going to work in that house and get them everything they need. So and explain to them why you're doing the heat load, why you're walking around the house and measuring the windows and the doors. Insulation has changed since that original boiler went in. Windows have changed. Yeah, maybe an addition went in and we're still going to put in a smaller boiler. So if we spend that little bit of time and energy, you know, obviously you always know when you do a great job, they become your disciple for you. So, and yeah, now you're getting a smaller boiler. It's probably less expensive than the old one that was there. Easy to carry, easy to pipe in, you know, all that other jazz out there. So it's just, yeah, it's interesting. And we got to really pay attention to that, I think, as an industry and as a trade.
Something Wheels brought up earlier, and it's from a discussion I had with a customer once who just couldn't understand doing. If I'm putting in a ModCon boiler, he said to me, if I'm putting in a ModCon boiler, why bother with a heat loss? It's not going to be too big. It's going to modulate down and be the right size. And why waste my time? Time is money. I got a lot of crap to do. All right. If I don't have to waste my time doing a heat loss, just slap this thing in and let it find its happy spot. I'm good, right? I haven't oversized anything. No, you're not oversized technically on the high end. You'll probably be oversized on the low end. And again, the boiler that you're putting in that has an 8-to-1 turn down ratio might in reality only have a 4-to-1 turn down ratio or a 3-to-1 turn down ratio. You're charging them for the whole boiler and you're only giving them half of it. Again, you start thinking about these things, and if you look at it in those terms, and would you as a consumer accept that crap? If you think about it, I'm going to charge you full price for this boiler, but you know, you're never going to use half of it. It's just there. You're paying for it, but it's never going to do you a flipping bit of good. No, it's not. That's as a consumer, I'd put my foot down and say, you know what? I don't think so.
John,
I want something that's right.
you might clarify. I don't think Steve was saying that, right? He was giving you an example of what others.
He was giving me
said.
an example. Yes, he wasn't saying that you should do that. No, he made that remark earlier. Yes, let me clarify. That's not, Wheels was not saying that's what you should do. He was bringing up the discussion that he and I had about this particular instance. Yeah. So no, he didn't say go ahead and do that. That's all right. No. He was saying, yeah, it's like that conversation. You know, we were talking about something else. It's like that conversation. So I just want to make sure. Yeah, make sure. Jason's got. Okay, Jason, breathe. You're good, man. You're good. Do it right the first time. But yeah, why would you sell a boiler with an 8-to-1 turn down ratio, but say, you know what, you're only getting half of it, man. You're only getting 4-to-1. I know you're paying a lot of money for that 8-to-1, but you're only getting 4-to-1. Oh, that's stupid. It's just it's mind-boggling to me but people think it's okay, and I get it. I get it. Time is money. We only got 24 hours in a day. We only got 8 hours of working time plus whatever else we got. We got a lot of crap on our plates, man. And sometimes the easy answer is the best one. All right.
And my
Sometimes
customer's
it
not
is.
freezing to death. Yeah.
Yeah, as
And they're
long
not
as they're
freezing.
not freezing to death and blaming me, I'm skating out of here, man. And it's not lazy. It's not stupid. What it is it's reality. There's the real
Mhm.
world. The real world is a harsh and unforgiving mistress. Sometimes you got to deal with that. But there's
I'm not. Yeah.
there's never a downside to taking a step back, taking a deep breath. Let's do this right. Let's make sure we're giving our customer their money's worth. All right. And that's the thing. Make sure they get their money's worth. Their money is their money, and you want it, but you want it ethically. You want them to feel good about paying you, not feel like they're getting screwed. So that's the basis of a long-term mutually beneficial relationship. So
You know, that plays right into that subtle little hint I gave earlier. I said, I threw it out there to say, how often do you think the boiler in a central heating call ever goes to high fire?
right.
So give me some feedback. We still got, what do we got? 53 people on here. Give me some feedback. How often, if you're doing ModCon boilers, wall hung, floor mount, whatever, how often do you think that unit ever goes to high fire during a central heating call? Give me some feedback.
I got an answer for you.
About the same thing as the variable speed circulators finding their proper speed.
Yeah. Richard
Never,
McGrath says never.
Richard, 3%, maybe.
If you're lucky, yeah.
Yeah.
That's maybe the
Only
best
during
you can hope
design
for.
degree days? No, because they're always oversized.
Yeah. If you're lucky, if the planets are in a line, if Jupiter is in the 7th house, no, if the
Jupiter-
moon is in the 7th house, and if
Jupiter
Jupiter
aligns.
is aligned with Mars, and
Yeah.
peace will guide the planets and love will steer the stars, you
Mm-hmm.
might get 3% of the time. Because this is
Yeah.
the dawning of the age of Aquarius.
Yeah, it goes back to just the oversizing thing. And thanks for that fifth dimension play. But
Daniel got it.
some people, here's another one. Some people think the boiler goes to high fire on a domestic hot water call. How many think that?
No. And you mean to say it doesn't?
I know for a fact it doesn't. I already gave the answer away, so no one's going to answer.
Yeah, so no one's going to
throw it in.
in.
John, you pulled it out of me.
I didn't even want to say anything because you already said it. So.
Anyway, that's food for thought. The boiler, most boiler manufacturers, I won't speak for every one of them, but the majority of them, when you give it a domestic hot water call, you're just giving it a set point demand. That's all it says. It says if it can reach the set point at 50% firing rate, that's all it's ever going to go to. Okay, it doesn't go to high fire just because you give it a domestic hot water call. So anyway, it has to do with,
goes to high temperature.
Yeah, it goes to high temperature, that's set point. And
Yeah,
if it can
that's
do
just-
it at a
that's just
reduced
thought,
firing rate, it doesn't have to go to high fire. So,
Right.
lots of people are misconceptions out there about
It's semantics, I think, too. We say high fire, but it's really high temperature. So I think a lot of times it's semantics, like we always say, heat rises.
Mm.
We know it doesn't. All right, it's just semantics and how we say it. So same thing. Yep.
That's right, Dave. Heat doesn't rise. Those were always part of the fun days back when we talked about radiant floor heating.
That's right.
And Jason says this, which is good to know, is that some municipalities or jurisdictions do require a heat loss calculation for a building permit or for a permit to change a boiler, and that's a good thing. And in addition, a lot of these jurisdictions are all code agencies or whatever that are offering energy assistance programs for loans and things like that. To get that loan, to qualify for that loan, you do have to do a heat loss analysis. You have to, have some cases you have to have the house HERS rated or something like that. So there's all these different requirements that are in place to say, hey, if you're going to get our money to help this, I know with a Mass Save, we give you an interest-free loan, so those things are terrific. But to get it, you're going to have to do this job right. Okay, there's no rule of thumb, man. There's none of that nonsense. Well, let's measure the baseboard and go from there. No, you got to do the math. And here's the thing about the math will never lie to you. The math will never steer you wrong. It will never lie. It will never steal. It will never cheat. The math will set you free and tell you the truth. God, this has been a fun night. I've had rants and I've had these loving sermons, and you guys are what this is,
and a little mythology too built in.
And a little Greek mythology, man. You're gonna miss me next week, aren't you? Admit it, Rick. Admit it. You're gonna miss me next week.
Absolutely.
Yeah.
There'll be more pressure on Dave and I.
Well,
Sir,
no,
yes,
you guys. Yeah. Now I want to know from the 52 guys that are still left. Are you guys going to miss me next week, or not? Yeah. What did we? Crickets, right? What did Dan go say? Crickets. Yeah, we got crickets.
Samuel, yes from Jason. Yeah.
You want to know what I'm going to be doing next week? And Jay, no, there's one. Time will tell.
You might not be invited back. Who knows?
I may not come back. You guys,
he's got a stick.
Maybe I won't come back.
Look out.
And I'm going to be using these babies next week.
Yeah.
All right. Which ones? What are they?
Oh, these are Bridgestones. I'm not sure I'm going to be using these. I may use a different set. I have several sets. I use the Bridgestones. I may use the McGregors. I'm not sure.
Okay.
If I get these things built in time, I might use these.
Wow.
For those of you out there, you're looking at this.
Wilson, are those Wilsons?
No, these are sub 70. Sub 70.
Okay, you got a glare. Yep.
Yeah, just so you know, I do have a problem. Okay, I have a golf club problem. All right, we'll get some more questions coming in.
No, you don't have a problem, a golf problem. You have a work problem.
I have a
Douglas.
Yeah. Yeah, I've got a problem that work gets in the way of my golf habit. So yeah.
Well, actually, this year it's been COVID's in the way of your golf habits.
Yeah, COVID's been in the way of my travel and all that. Yeah, I hear you. Here's a question from Roger Brenstatter. If you had a 4-zone baseboard job with 95,000 BTUs of installed radiation and 110,000 BTU input replacement boiler that had a net rating of 85,000, should you go to the next bigger boiler? No, you should do a heat loss and find out what the real heat load is, Roger. And I don't mean to be flippant on that answer. Here's the thing about measuring the baseboard and multiplying by 500 and considering that that's the load, or that's the installed radiation, and my boiler has to support the installed radiation, right? No. In a forced hot water system, the boiler has to offset the heat loss. It has to offset the heat loss. It doesn't have to support the installed radiation. That's a leftover myth from the steam days. A steam boiler has to support the installed radiation. And a hot water boiler has to overcome the heat loss. So in your example, Roger, I'd say, I'm not worried about how much baseboard's installed. What's the heat loss of the house? If the heat loss of the house is 70,000 BTUs, I'm going to go with 70,000 BTU boiler, and we'll be fine. It'll work great. Understand that the output of baseboard varies based on the water temperature you run through it. All right, it's not always 500 BTUs. I can run if I've got if I've got an over-radiated house, meaning I got way more baseboard in every room than I need according to my heat loss. Now what do? Now you know the load, right? Now you can start. I don't have to run 180 degree water in here. Hey, maybe I can put in a modulating condensing high efficiency boiler, and I don't even have to run it up to 180. I can say maybe I only need, under design conditions, maybe I only need 140 degree water in here because way too much baseboard is installed. All right. If you've seen those houses where their baseboard sizing method was measure every available inch of wall space and then install that much baseboard. All right. The output per foot of baseboard is going to vary based on the water temperature you run through it. The thing to do is figure out how many BTUs I need for a room. Look at how many feet of radiator I have in there and say, how many BTUs do I need per foot? All right, maybe I don't need 500. Maybe I only need 250 BTUs per foot out of the baseboard that's installed in this room. Then I go check the manufacturer's spec sheet and it'll tell me I only need 130 degree water to do this. Hallelujah. Now that sucker's going to condense all the time, and I'm really starting to make a difference in the efficiency. So that a rant?
That was my house exactly, which is my in-laws house. So my in-laws house, I did that. So I swapped out that old cast iron boiler, put in a nice wall hung boiler, did the heat load on it, found that I only needed the highest water temperature I needed on a design day was 150 degrees. So 150 degrees going out, put a Delta T pump on that, coming back at 130. So on a design day, the boiler's just starting to condense. All right. So that means 97.5% of the winter, that boiler's, seeing some nice cool temperatures coming back to it. So one thing about that though, make sure your customers know that you're modulating the water temperature when it comes to fin tube baseboard.
Oh boy.
All right. Yes. Because in this house here, it was my in-laws' house, and it wasn't mine as it is now. I remember that first cold snap, really bad cold snap happened here in New York, and I'm away on the road again doing training class. I think I was down in Baltimore at the time. And I happened to call here at my in-laws' house to talk to my wife because I knew she was here. So, and of course, my mother-in-law answers the phone, and I'm cordial. I start talking. I say, "Oh, by the way, how's the heat?" And she goes, "Oh, yeah, I've been meaning to talk to you about that. I don't think it's working. I don't think it's on." And I'm like, I'm in Baltimore for the next 4 days. And I'm like, "What?" And in that 30 seconds, what I'm thinking is, what do I got to do? And who do I call to get over to the house to take a look at it? And I said, wait a minute. All right, Ma, hold on a second. What's the temperature in the house? And she says, well, it's 69 degrees. And I said, well, what's the thermostat set for? She goes, 69. So if you do the math, that's working.
Yeah.
I'm like, what do you mean it's not working? She's like, well, I don't hear it anymore.
Yeah.
But she didn't hear the rush of 180 degrees going into fin tube baseboard that was way oversized and ticking along and expanding and contracting because, put the outdoor sensor on it, lowered the water temperature, got a variable speed pump on there. I'm modulating the world, and she didn't hear it anymore. So make sure your customers know that, because I've heard this story plenty of times where the guy puts in that new boiler, puts the outdoor sensor on it. He comes back because the homeowner says it's not working and disconnects the outdoor sensor and says, screw it, give me 180 all the time. So don't do that. You got to tell them what to expect out of the system, because or the worst part is, we've been told by the government as a homeowner what's the best way to save fuel oil or save fuel. Set back thermostats and set it back 10, 12 degrees. You put a boiler on outdoor reset, do not do a 10 or 12 degree setback. You could still do a couple, but don't do a 10 to 12 degrees, because then it takes a really long time to come out of setback in the mornings. So got to watch out for that.
Yeah, no more. I look at no more than 3 to 5 degrees for no less than 6 to 8 hours is a good way to think about setback, in my opinion. Roger, I hope that answer wasn't too abrupt for you. I just want to make sure that makes sense. So if you could just send in a message, does that answer make sense to you, yes or no? And then we can continue that discussion, because it's an important one, and I hope that info was helpful to you. So terrific. What does Steve Racy have to say? A few years ago, Taco used to have a quick hands challenge in regards to the 007 and other circulators. That's for swapping out the cartridge, right? And that was a long time ago. That was before my time, I think, at Taco, pre-2007. Can you do the same with an ECM circulator? And by the way, I had the top time at the CMPX show in Toronto and won a real nice Taco leather jacket. How about that? I had a 47 seconds at the show. I've since improved to 33. But still charge a minimum of 1 hour. I love it. I'm sure we could do a quick hands, but the thing about the ECMs, they don't have a cartridge per se. They just have that cylinder.
Yeah, when you take the casing apart, you take those 4 bolts out of here. There it is. We don't have them as replacement parts anymore, because the bearings, so to speak, the graphite bearing is already on the inside there. So you can see that side there, and it slides in and grabs onto this outside edge here too. So, and the magnets are holding it in. We don't have them as replacement parts because of the way the manufacturing is happening, and because of the sure start. We're not going to see burnt out bearings in a cartridge any longer.
Mm-hmm.
All right, so a lot of that has been replaced and whatnot. So today's world is, if that circ goes dead on you, then it's replace the circ.
You
So,
guys, you know,
yeah.
out west, I run this past all the reps that I end up working with. It seems so long ago. I ask them, no, remember you walk into a wholesaler or you walk into a rep and they've got this little bone pile of something that's accumulated. That's one thing you won't see with any of these Teco Italia platform circulators. I've asked all the reps out west, how many do you get of these do you ever get back? And then it's always goose eggs. We don't get these circulators back. What they'll say is, yeah, I had one come back because the guy dropped it and he broke the flange. You know, so that's the only time these circs come back. So you won't be changing any cartridges. So.
Yeah. Richard McGrath says, John, stay out of the water. You'd be a nice meal. Thank you.
Ooh.
I'm not going golfing in Florida though, where the alligators are. There aren't any alligators in Vermont. Okay, just so you know this. It's to the best of my knowledge, there are no alligators in the mountains in Vermont. I'll come back with a full report on to verify that, but from what I've been told, there are no alligators in the mountains in Vermont. So just want to make sure. Let's hope so. Anyway. Okay, Nick Sarando. I have a situation where a standard efficiency boiler was installed in 1988. The home has cast iron radiators and radiant was installed in the basement and convectors were added in the enclosed porch. Is there a way to make this work? So you're looking at 2 temperatures, Nick, or 3? If it's
Probably
a
a 2-temp system. I'm seeing a 2-temp system with the radiators and the convectors looking at the high temp and then the radiator.
Right. Yeah,
So,
that's what I'm thinking.
So it depends. I mean, yeah, you got the full basement of radiant. So, we always have that concern of sending back that cold water from the radiant to the boiler. But, cast iron radiators and convectors, the volume of water that you have there, and compared to the flow of water coming back from the radiant to a lot of people always talk about shocking the boiler, a big old cast iron boiler with radiant and it's low temperature, you're going to shock it. Here, you're not even going to surprise it. Right? It's just it's a trickle of cool water coming back to that boiler. So
going to surprise it. Oh God.
it just doesn't even see it coming, So I mean, I've seen people, oh, you got to do primary, secondary, and put major controls on it. Just put the mixing valve in, circulator, and you're done.
Oh, I'm done. You're going to surprise it. All right, good. Yeah, Terry. Yeah, hey, Terry Turner says, no, we're talking about great whites going to the beach. Yeah, that's true. If you stay out of the ocean, because now we got great whites running around here. I don't think I'm going to be, again, there's no oceanfront property in Vermont either. Now, could be that big lake up there, the Lake Champlain, they have their own monster there, like Loch Ness. They call him Champy, or the Lake Champlain monster. Now that might be trouble, but otherwise I think we're going to be all right. Anyway, all right. Let's see what we got here. Yeah, the rads run at 160 to 180, as does the convector. So yeah, we're talking about a 2-temperature system. Yeah, I think that's going to work out all right. All righty. Let's see. No alligators in Vermont. I hope so. I hope there's no alligators in Vermont and no sharks. Okay. I don't even know. There's snakes. I don't like snakes, but I don't want to meet the snake that could eat me either. That'd be a big ass snake.
Yeah, in Vermont, I doubt it. Yeah.
Yeah, that's bears. It could be a bear. We could run into bears in Vermont. That is possible. That's all right. Okay. And what wolves and wildcats? Yeah, they call them catamounts in Vermont, don't they? They're the catamounts. They're like mountain lions. They're called catamounts. I think that's what they're called in Vermont.
You might see a squonk.
A who?
A squonk.
What's a squonk?
It's that mythical creature that they used to go out and catch, and because he cried so much, it would go right through a gunny sack. And by the time they got home, they didn't have the creature no more because he cried himself away. Squonk, S-Q-U-O-N-K, I believe. But they're up in that area, Pennsylvania and such. So
is that like going snipe hunting?
I don't think so. Snarping.
Snarping.
I got a picture of a squonk. I don't know if I can show you or not, but anyway,
Yeah.
I don't want to.
When I was in high school, when we were out cruising, we'd go boley hunting. We'd be out looking for bolies.
Were you a Steely Dan fan?
I was always been a Steely Dan fan.
One of the tunes that says, "Have you seen a squonk's tears? Well, look at mine."
Have you seen a squonk's tears? Well, look at mine. Ah,
Yeah.
okay.
Yeah.
Yeah. Any major dude. What a great song. What a great song. Now I know what he was talking about.
Yeah.
The things you learn at Takeo training.
Hey, useless information.
You can't shock a boiler. You sure can surprise it though.
You might surprise it. No, he said you wouldn't even surprise it.
You wouldn't even surprise it. No, I mean, that boiler sees you coming, man, just like the squonk.
Oh man, I've been down here too much today.
Yeah, and just for the folks that are left out there, I'm in charge of this group, okay? So I don't know if it's a lack of leadership or what.
Lead by example.
But I've got one guy talking about squonks and one guy trying to surprise a boiler. So, yep. I feel like I'm Captain Parmenter, and this is Sergeant O'Rourke and Corporal Agarn. There's a reference. Put that one out of your surprised boiler there, boys. Squonk me this.
I don't know.
There you go. You don't know about Captain Parmenter and Sergeant O'Rourke and Corporal Agarn?
Does not ring a bell.
Oh, ho, ho, ho. Dave? Now Dave's Googling it. Dave's showing a little initiative here. He's Googling it right now.
I'm not even listening to you guys anymore. I tuned you out.
Oh, well, there you go. Okay. Jerry
not
McPeak's got it. It's F Troop. Thank you, Jerry. One of the great sitcoms of all time. Where the heck are we?
Are we?
Great politically inappropriate show for today, but funnier than heck in the 60s and 70s.
Watch what this head thing does to my head. Watch this. Can you guys see that little lump? Look at that.
Oh my God, your head is dented.
It comes right back, but for now, it fits right in there. It's like a notch.
I think I'd get that looked at. It's a little soft.
Yeah, well, it's soft. That's a soft spot.
These are my guys. I think I'm going to hang with Rich and Brett for a while, I got to go. I have an appointment back on the planet Earth, okay? Oh, dear. All right,
God
guys.
that everybody's still here to see all this. Yes.
Yeah, well, there's still 40 people out here that actually have no lives and nothing better to do at 9:30 on a Wednesday night.
Well, come back and see us next week. We're gonna evolve the ECM conversation one way or another. Dave and I haven't figured it out yet, but we have some good things that we've tossed back and forth. So yeah, we'll give you some real good information. So please come back and see us and spend some time with us.
What goes where and why on circulator size, what Rick is doing. I'm going to do a little near boiler piping, pumping away and parts and pieces around that too. And maybe even a little bit more circ anatomy is what I was kind of thinking about too, Rick.
Good.
So maybe we'll throw some circ anatomy in there in the AC and ECM world. I did a little bit tonight, so.
Okay. Very good. Very good. And we've got two more. We got next week, and then the final summer session will be the week after. And I think we're going to try and put together something kind of special for that one. We think we'll have a reunion of all the special, I guess, speakers and maybe some special guests that have been in the audience and would like to kind of partake in the presentation portion.
Great.
So it'll be a round table. So it's going to be kind of special. We're really looking forward to that. And that will work. Well, you got a request on buffer tanks. Don't forget about buffer tanks. We will definitely discuss those, whether if not next week, the week in our final session. So hope you guys have enjoyed summer school, Takeo After Dark, the summer school sessions and session 6, which definitely took some pretty weird turns. It definitely went to places unknown, but thank you all for sticking with us, and we shall see you. Well, I won't see you next week. I will be thinking of you as I'm battling the sharks and the alligators in Vermont.
And the squonk.
And the squonk. Yes, I will find a squonk's tears and look at mine. So
yeah.
All right, folks. Take care. Thank you all, and we'll see you next week.
Yes,
And
definitely. See you guys later. Yes.
There you go.
Peace out.
Peace out. Later, guys.
Enjoy, y'all.
Thank you.